So just hit connecting to the internet. And then we want to go back to his presentation.
Generally speaking.
Is it us? Online? This one. Okay, so because somebody just, Matt just texted and said that it's not online. He said it came on for a second and then it's not. It'll be live now.
Yeah, and there's fruit over there. Do you want to watch some grazing?
Good job. Well, we're having next week. Right now I can see him really well. Okay. People are not. I can see. Is it? So is it? So it is on YouTube. We're up.
I think sometimes too, it's just like people that don't learn to drive until they're older and they kind of just are more nervous about it. And then compared to like sports, maybe it's never been on the trail or not, might not on trails to this older.
Okay, so you're ready whenever we are? Right. What else do we need? Okay. What's that? Oh, no, we're she was shooting ginger still.
Yeah, I'm very
And she hadn't seen cows before. But she figured out those guys are more intense.
Nikki, are you ready? Laura, are you ready? Are you guys ready?
We're live. Good morning.
It's not working.
Good morning. Welcome. We're going to begin, and I would like to invite everyone that's at the back of the room to go ahead and come forward and find a seat. My name is Brandy Reed. I work with the Keene Conservation District, and thank you very much for coming and joining us for this conversation around climate change and horsekeeping, managing the uncertainty. Our major partners in this endeavor are, in addition to the Keene Conservation District, Horses for Clean Water, which I know many of you in the audience are familiar with Elaine's work. We also have our major sponsors, which are on the slide behind me: Snohomish Conservation District, Lighthoof, Trinity Ranch, and some of our other partners, King County Department of Natural Resources, etc. there. And the conference is being streamed live as well, so we have a remote audience, and I'd like to welcome everybody in the remote audience as well. We are experiencing a little bit of a technical difficulty with the live stream, and I'll just ask everyone that is remotely participating to bear with us while we try to get that. It's been fixed. Very good. Thank you. Okay, so today we've brought together a number of specialists who work at the intersection of climate change and agricultural management and livestock management. We're hoping that that you will enjoy how we have laid this out to explore the question of climate change and how it might be impacting agricultural commodities that horse keepers rely on, and also looking at some of the health and well-being impacts that might be coming down the line or that you are already experiencing related to changes in weather patterns. The goals of our conference are to have this conversation with you about climate change and what it looks like in the Pacific Northwest, what do we think is happening, what don't we know, what we have to just sort of deal with on an uncertainty level, and also the horse, excuse me, I seem to have lost my mobility of my tongue, the horse health and well-being component, which is largely focused around, do you have what you need to keep your horses healthy? Are you dealing with problems associated with pests and diseases? So the objective is to go over all of that with you, and all of us to raise our literacy level on these topics together. And then also, we're hoping that this is the beginning of an ongoing conversation with you, because as you know, the Keene Conservation District and other conservation districts in Washington State and throughout the country work with horse managers and livestock managers in general, and we want to ask the question, how can we better serve you as a large percentage of our cooperator base in addressing environmental quality issues and helping you figure out how to adapt your resource management practices to address whatever sort of pressures you might be experiencing. So having that ongoing dialogue with you is going to be important to us, because we need to know how to be really responsive to your needs, and having that conversation is just going to help us keep track and keep pace with that. We also want to make sure that we get into some details around talking about specific management practices and how we might adapt those management practices in the face of what we're looking at around climate change. So the first half of the day will focus on the science and what we know about climate change and what we know about the impacts on agriculture and on horse health and well-being. And the second half of the day will focus on some of the core management practices that we had time to fit into the schedule of this conference. We'll focus on pasture management and water conservation, and get into the details of those practices and how we might want to think about changing and adapting what we currently consider to be A+ management practices in those areas in the Pacific Northwest. Okay, and just a little bit of housekeeping before we get started. Everything that we are doing today is going to be in this room here, this one large room. So just to orient you, if you're coming in late and you haven't had a chance to get oriented, restrooms are in the back of the room opposite of me. There are vendor booths around the side of the room, and our refreshment table is over here on my left. Feel free to move around and get refreshments during the session, and our vendors and our sponsors who have their information booths are available to meet with you during breaks. We do have a number of breaks scheduled, and at the end of the day, they will be here for a little while if you decide not to go on the optional tour of the facility, which we will get into a little more detail later. And then the other thing that I have been asked to share with you by the presenters is that they do not mind at all being asked questions in the middle of their presentation, so feel free to be interactive throughout the day. And those of you who have cell phones, let's go ahead and silence those now so that we can not have that interruption. Okay, so we are going to begin the morning session with Mr. Nick Bond. And, excuse me just a second. Nick Bond is a Washington State climatologist, and he is a principal researcher and meteorologist at the University of Washington Joint Institute for Study of the Atmosphere and Ocean. And he conducts research on a broad range of weather-related topics, and his focus is on weather and climate change in the Pacific Northwest. So that's very, very pertinent to us. And he likes to focus on the linkages between climate and marine ecosystems. And he cheerfully admits to being a weather geek, which I love, being kind of a geek. And he also prefers to spend his summers in winter climates, or no, northern latitudes.
Yeah, I like to go to Alaska in winter and places like Florida in summer, just so I get the kind of weather extremes in. So
welcome.
Yeah, thanks, Brandon. So I don't know how many of you have lived in the Seattle area for a while, but you remember the cartoonist David Horsey, the PI? I think he was great. And this is, obviously it's on a somewhat different topic than the focus of today, but I think it's kind of apt for this present gathering. What I'm going to talk about is going to kind of set the stage in terms of what we're seeing right now in what's happening to the climate in the area, and what we're expecting in the future with some implications. Hopefully I'll be able to scoop some of the speakers that follow. That's my goal. About halfway through, there's actually going to be, not only encourage questions, but there's going to be an audience participation part. So you're forewarned.
Can I get you to stay in one place?
Sorry.
Thank you.
That's right. Yeah. The main thing that we're worried about is not just that the temperature is going to go up a little bit and all that, but it's really what climate change is going to do to the systems that we rely upon. The availability of water, food. That's a big deal. Growing population, food security, our ecosystems and all the services they provide. Just the risks themselves of extreme weather events. And so this is kind of a doom and gloom slide, but it's, there's some real concerns. What, some of the questions that are associated with it, first and foremost, is the climate changing? Yes, it is. It's not changing extremely fast, but it is changing. I'll show you some evidence here for the local area of that. What are greenhouse gases, and do we understand their role in climate? To a large extent, we do. We don't perfectly understand them, and that's an area that I'm involved with in research and so forth. The impact of human activities on greenhouse gases, this we're pretty comfortable with. You might see something, volcanoes pump out a lot more CO2 than the combustion of fossil fuels. That is actually not correct at all. We are responsible for the increase increases in greenhouse gas concentrations that are measured very well, and there's no doubt about this one. The last one here is the big question, the $64,000 question. Can we predict climate change during this century, and with what confidence? And that's something, an area of active work. We aren't perfectly confident how exactly how it's going to play out and how fast, but there are some things that we're fairly confident about, I would say. Okay, is the climate changing? I could put up some, and I will put up some temperature plots and that sort of thing, but I think in some ways a more telling thing is just from photographs. Here's a picture made in the exact same place of a glacier in the southern hemisphere, almost 100 years ago, and in the present day, big shrinkage. Has anybody here been to the Portage Glacier outside Anchorage, Alaska? Okay. At the visitor center there, you can no longer see the glacier. That visitor center was not built that long ago, and it's still a quarter-mile hike to actually go and see it. But it's a sign that this sort of thing is happening. One of the things that's alarmed some in the climate community is the rapid decrease in Arctic sea ice at the end of summer. It still gets cold and dark in the winter. Ice grows every winter. But the kind of permanent ice pack is going down and down. Some in the media, they pointed out in this last summer that there was some recovery, and they're saying, oh, it was so much more than the last summer, climate change is a crock and all that. It was still the 6th lowest on record. And the trend there, I would say, is unmistakable.
So were there similarities between the 2013 and, let's say, the 1995?
The kind of the weather from one summer to another has a lot to do with it, and the weather was especially bad for sea ice in 2012 to have almost all of it go away, and it wasn't as favorable for the loss of sea ice in the 2013, and so that kind of the weather fluctuations are these kind of year-to-year chatter on this, declining trend.
Maybe when there's questions, if you want to repeat them,
Oh,
that'd be great.
yeah, thanks. Yeah, so, any other questions? Yeah, and I'm glad you asked that. Okay, what about more of, we don't live in the Arctic, right? In the U.S. itself, the actual observed changes from the kind of early part of the 20th, or first half of the 20th century versus kind of the present climate, there's general warmth, but it varies from place to place. The southeast, for what it has hardly, and so for the long-term residents there, you could understand how they'd be skeptical. I haven't seen any change, it's not happening. But for the country as a whole, it has. If we take a little bit more of a look at the Pacific Northwest itself, and in particular, look at the seasonality of what we've seen. A recent paper that was just published by some colleagues of mine, break it down in winter, March through May, spring, summer, and fall. And here in the max temperatures and in the min temperatures for Washington, Oregon, Idaho, and western Montana. And one of the screaming messages you see is that different seasons we're seeing different long-term trends. One of the things that I'm particularly interested in and have done some work on is what's happening in summer, that we see more of a change in the minimum temperatures, the nighttime temperatures, than in the afternoon temperatures. The other thing pointed out, not much change in spring. And that there is, from station to station, there's variability, but the redder the dot, the more it's warmed up. And so we'll get back to this, but the idea that it's getting warmer at night. All right. Here, just a kind of a different way to look at it, in kind of emphasizing the year-to-year changes in the temperature. Here, this is for that same basically that same area, the Pacific Northwest as a whole, relative to the normal, and these are annual averages. What I'm struck by, maybe there's a slight upward trend, but the main thing is just extreme fluctuations from year to year and even decade to decade. We've had periods in the kind of 60s and early 70s that were kind of chilly and then kind of warm up. Last 5 or 6 years have been on, relative to the recent times, have been kind of cooler around here for the Pacific Northwest as a whole. And so that's partly why we don't really feel climate change yet, because the variability isn't so much dominated by kind of upward trends, but kind of year-to-year changes. Here, let's get back to this idea of kind of warm summer nights. And in particular, a paper that was, well, I guess I didn't indicate it here, was published by the State Climate Office. We looked for Western Washington and Oregon, just the west part of the Cascades. We looked at the top 1% of the kind of hot night events, and we looked at the hot day events also, going back to the 1900, and there is decent station data back there where those temperatures are reasonably reliable. What's plotted here is when those kind of very extreme hot night type of events occurred, with year across the bottom here, and the summer day from the end of June to kind of the end of August here. What I mostly want you to focus on is how few events there were up until the kind of the 80s, and then all of our kind of hot night heat waves have been, almost all of them, in the last couple of decades. You might recall here, this ends in 2009. Was anybody living around here in 2009? And how uncomfortable that was? That also was a hot day event, but what I was especially struck by was how warm the nights were then. And when you do the same sort of thing for the hot day type events, they're sprinkled throughout the record, and so we don't see any trend in the greater occurrence of the hot days. It's the hot nights. One of the reasons we see that is it is getting more humid here in the summertime. This is water vapor content, just a measure of the humidity. Here we probably have decent records, and this is a little bit above the surface, but kind of about a few hundred meters up, just to get away from kind of local effects, urban heat island stuff and all that. But here from 1950 through last summer, and here it's a June to September average for the state as a whole, you can see, the chatter from year to year, but this increasing trend, 2013 was a record. We have some other spikes in there, kind of as an aside. El Nino, when an El Nino gets going early in the calendar year, we tend to be humid here in the summer. That's kind of happening this time too. And so I'm going to make a forecast, and you can, going out on a limb and that sort of thing, but we're going to have another kind of humid summer like last summer, partly because of this kind of trend and some other things that are going on this year. Anyway, this helps explain anyway, why we're seeing hotter nights around here. It's, you might recall, in the desert it cools off nice at night. In Biloxi, Mississippi, and awful places like that, not so much, right? And if anybody's from the heart of Dixie, my apologies. My father's from Tennessee, so I can make jokes like that, right? Another thing that we're seeing here, and I was just talking to Chad Kruger about this, is kind of at the same time we're seeing some greater humidity, we're seeing it getting sunnier, and we have measurements back to the late 80s in the Columbia Basin of eastern Washington. And this may have implications for agriculture, maybe higher production, more sunshine, more energy to grow plants and that sort of thing. But this means there's a greater water demand also. And again, there's kind of year-to-year changes. It has flattened off in the last 7 years or so. I'm not saying it's going to continue to go up, but I think this change is actually fairly remarkable, and I found it to be a surprise. In terms of precipitation, yes, question?
On the last slide, what were you measuring?
Yeah, good question. Here is the actual energy, the insolation by the sun. And so how much energy per meter squared is coming from the sunlight. And so it basically, what this is saying is it's been less cloudy, and this is just in the summer, in recent years versus the late 80s, early 90s. And so it's just kind of how much heat energy is coming from the sun, or radiant energy. Yeah, I forgot to repeat the question. Okay. Getting back to a little bit about more what we're observing, precipitation trends, fall, summer, winter, not so much. Spring is getting wetter around here. Again, the time period is last, you can attest to that. Last spring wasn't actually so bad. I'm expecting the remainder of this spring to be near normal or even a little drier than normal, but certainly in 2012, 2011, 2010, it was wet, and it seemed like summer was forever to get started. And so that is actually starting to get reflected in our trends. But right now, this is consistent with mine, that we're not really seeing big changes in the climate here with, maybe a few minor exceptions. Okay. Getting back to why we believe that this is kind of a problem is that the basic science of greenhouse gases is actually very well understood and accepted by basically everyone who has any sort of physics background to speak of. And the idea there is if there's, I'm going to get technical, stuff in the atmosphere, then and it can be water vapor, clouds, CO2, methane, that sort of thing. That stuff radiates energy down to the ground that keeps us warmer. We're actually have personal experience with this. What kind of nights are colder in the winter? Clear ones. Yeah, clear and dry ones. When there's less water vapor, that's a potent greenhouse gas that's kind of radiating downward. So when it's cloudy, we rarely get extremely cold. It's those clear nights when we don't have the source of energy. One of the important greenhouse gases, of course, is CO2. This is, we have a good idea of what the concentrations have been in the atmosphere back hundreds of thousands of years from looking at bubbles that are in ice cores. And so this is going back 400,000 years ago from a sample in Antarctica. We're at this current level. So we're in uncharted territory in terms of the kind of geological past, at least in the And here is from our models, imperfect models, but our best way of kind of estimating what's going to happen. The changes from the kind of, more or less present climate to the middle of this, the century. Here, somewhat greater warming east of the Cascades, especially in the Columbia Basin. These changes, this is wintertime for what it's worth, maybe don't really alarm you. Part of the reason we don't think it's going to change as fast on the west side is that we have that big Pacific Ocean upstream of us, and the prevailing winds are from the west, and that's going to kind of buffer the changes we see. So maybe you aren't so alarmed by this, but this is more, when you get to the 2090s, this is more kind of Dante's version of what the climate of Washington State. And if you're a sinner, maybe this is something that you're used to. Maybe I should go there. Question in the back.
Well, I'm still about 10 slides back, just trying to, I'm still trying to answer the question that was asked. Because you said that in the east, when you did that measurement for the direct energy, right? You said
Right.
it's because there's more clear days.
Yeah.
So repeat.
Yeah, you're saying that the warming comes from the reflections of stuff in the ozone, right? So I'm just struggling a little bit with reconciling those two.
Yeah, the question was, I had showed a previous slide that it shows is it getting sunnier in eastern Washington, and that, which kind of implies that maybe there's, kind of less water vapor and less things, at least to make clouds there. Yet this slide here and the previous one indicate a greater rate of warming in eastern Washington. And for starters, this I actually just picked the winter months here. And it's a kind of a different deal than summer. But this is kind of an example of somewhat contradictory results that are coming out that we are trying to resolve. And so I'm not going to try to paper over that we don't fully understand how to reconcile what we're seeing in the models that are still our best estimate of what's going to happen with what we're actually seeing now. But kind of a longer answer, there are some reasons why you could have both too. So thanks for the question. Another question.
Right, so there's apparently a tendency for the warming to be mid-Washington and south. What's the speculation about the more warming north? Where does that, how, because they've got salt water to buffer them as well.
Yeah, that's in general, and I think, I hope I have a slide on that. We are expecting greater warming at higher latitudes than lower latitudes. Yeah, just because all around the Earth, and you can kind of see a hint of that southwestern Canada is getting greater warming than in general than the South, and so that's part. more an increase in winter or summer air pollution? So yeah, we're thinking summer, and in particular, if we have maybe kind of a lower emissions scenario, and this is at the end of this century, and we continue to clean up our act, we'll actually have, and this is for ozone, decreases nationwide in ozone concentrations. But if we don't clean up our act and it gets that much hotter, then we're expecting higher ozone amounts. Is a very correspondence here. The blue trace is max temperatures at SeaTac during that hellish heat wave of 2009, well, the July and August of that hot summer. And if red is ozone concentrations at Enumclaw, not too far from here, and a place where a lot of people, it's in kind of the foothills of Western Washington, that gets higher ozone concentrations, the kind of witch's brew of pollutants that are put into the urban areas kind of drift into the foothills, and that's where you see the higher concentrations. And the idea there is that the more hot days, the more days with spikes of ozone. I have no idea if ozone is, it's harmful to humans. Is it harmful to livestock, including horses? My guess is yes. And we know it's harmful to the forests in this area. And so this is kind of I think a rather sobering sort of graph, because if we go back to here, right now we get, and in the foreseeable future, we're pretty wimpy in terms of heat waves. But that's not the expectation by the end of the century, that we're going to get a lot more of these hot days that, at least right now, are conditions right for the development of high ozone concentrations. How is the amount of precipitation liable to change? Oh, and the seasonality of it. Oh, wow. Oh, that's a tough one, right? Is it going to get rainier in summer, drier in summer, rainier in winter, drier in winter, which, both? Shout it out. I see some head shaking. It rains all the time. Yeah. All right. Enough suspense. Here, this is kind of a complicated graph, and so bear with me as I kind of go through this. This is the changes we see in percent by season. In each of these panels, it's for winter, spring, summer, and fall. 2020s, 2040s, 2080s. And what these little dots show are individual climate models, what they're indicating for the changes. Again, this is for the Pacific Northwest. And so these kind of boxes and whiskers show kind of the sort of the mean sense and the kind of variation from model to model in this. And at least in the next couple of decades, maybe not too much of a change, but with time, there's a consensus, if not a unanimity of opinion from our models, that it's going to be wetter winters and drier summers. What are the implications for, people, horse keeping? Well, I don't know. But one of the things that's going to happen is, again, with a warming climate, more rain rather than snow in winter, reduced snowpacks in the Cascades, and probably more pressure on summer water supplies. And so that's just what is kind of emerging from the results. Let's go back to the figure itself. Probably no immediate threat. We're going to be continue to have year-to-year variations of this winter ahead with El Nino. It's probably going to be on the dry side. We've had 5 years or so with pretty healthy precip amounts, so it's not like you should you're not going to have any water anytime soon, but it's something to keep in mind. All right. So I have Not too many more slides, but I do want to kind of indicate, get back to this message about the uncertainty in what we're seeing here. These are what our models are showing for different kinds of emission scenarios of CO2. This is if we kind of do a better job of curtailing the emissions. This is if we do kind of business as usual of what the changes in temperature are going to be with time through the rest of this century. And the screaming message here is no matter what we do, it doesn't make that much difference by the middle of the century, it looks like. Then there's also going to be all this kind of year to year and decade to decade variability. And that's just something we're going to have to deal with. And there's always going to be a relatively cold winter, and people know what global warming, that's BS. I mean, pardon me, but I can see everybody's deeply offended. That 1 year doesn't make a trend, and the important point is that trend is, it's going to be a while till that emerges. So, last I looked, this is what the topic is all about, right? And so in the interest of scooping some of the speakers that follow me and that sort of thing in here, I want to kind of, again, not being an expert in the field, some of the things that I think are probably pretty important. I showed before that it's getting more humid here. It turns out that horses are very sensitive, and I found a paper on this, to the heat index itself that includes the effects of temperature and humidity. And so even if our temperature doesn't go up, as humidity goes up, horses can get stressed that much more. And so that's now more of a problem in places like Florida and so forth, but conceivably gets to be more important around here. Another thing that is getting discussed in research is that as CO2 increases in the atmosphere, that is kind of a fertilizer for plants, but they tend to make their kind of properties change to a certain extent. And Chad is kind of nodding, so I guess he more or less agrees with this. But the idea is that their grasses may grow faster, but they may not be quite as nutritious. And again, this depends a lot on the different, whether it's a legume or a grass or alfalfa maybe is not the case, but just in general, there's some concern about this. There's also fears of increases in undesirable plant species. Around here, cheatgrass is a big thing. Yellow star thistle. I had a status for a high school PE teacher that he'd have a kind of a stick of star thistle as we'd run laps and would hit us on the back of the legs as we were running. Nice guy. Right? But yeah, this is not good forage for most livestock. And then I think there's one more. And this is something that I think Gary will be talking about, that the idea that there's kind of parasites and pathogens and so forth, that we're seeing some changes in that, and I'll kind of leave it at that. Now, I also dug up some stuff about in the literature on what is being kind of expected on climate change and impacts on livestock. I realize a cow isn't a horse. To me, they're both big animals that I'm kind of scared of, right? And so same thing. But the idea here is that as the temperature goes up, and there's been actually some measurements done at various places in Arizona, Florida, California, and that sort of thing, that milk production goes down because these animals are stressed. And what's kind of interesting here is the temperature doesn't have to be as high for these production losses in Florida because it's so humid already that they start getting these kind of, but at places like this purple one in Arizona, it's dry, and so it has to get really hot before you see a decrease in production. And so for that reason, and maybe this is good news locally, is because we're still relatively low humidity and not that hot, the expected changes, and frankly I forget what, I think this is by the late 2000s, in the milk production losses are mostly in the southern tier of states where there's already close to the heat stress, and presumably horses are feeling the same thing. So to kind of summarize what we're finding with the climate models, and what I'm going to take the opportunity to be a little bit of an advocate here, but I just want to summarize what I've been showing, and that is this theme that the kind of variations are going to continue to dominate any sort of long-term trends for the next few decades. We're seeing increases in minimum temperatures and humidity, not so much in maximum temperatures. We're probably going to experience wetter winters and drier summers, but there's a fair amount of uncertainty there. But, you know, I think this is, and again, I'm going to get on my high horse, pun intended, here, that this is something that is worth, that I think we should be thinking about, trying to do something about. And I think even the folks who are arguing that we shouldn't do anything about climate change would argue that it's a good thing to not let the climate go. We're adapted to the present climate, and if we can stabilize it, that would be a good thing, as long as there weren't too big a cost. And I don't think there's that much argument there. The idea there is then, how do we keep this, the concentration of CO2 down to a reasonable level? We've already put a bunch in. This trace here isn't the CO2 concentrations, it's just how much we're pumping into the atmosphere. That here we would like to kind of, it's growing now, the population of the globe is growing, a lot of development in China and India, and people want stuff. And so how do we kind of clip that rise there? The idea is that we can't do it, there's no single silver bullet, and that there's lots of things that we can do to kind of actually address this problem. We don't have to give up. And in particular, energy efficiency, that's a no-brainer. I mean, this saves money, conservation, why wouldn't you do that? Renewable fuels, that's happening. Here, I think we're going to be hearing a little bit more about pasture practices that can mean that there's more carbon stored in the soils, and that's a good thing. This is something for some environmental groups, that's hot potato. But perhaps we need more nukes to generate our electricity. We certainly should have a conversation about that. After the Fukushima disaster, there's some reluctance on that, and justifiably so. Maybe, you know, fuel switching, even doing CO2 capture and storage. But like the very last slide closed with, you know, it's happening, right? And so we're going to have to deal with it, and we are committed to some change in the climate. And so part of what I think the other speakers are going to talk about, and what I want you to think about is, you know, how do we adapt? How do you kind of maybe change your practices so that you can take into account what we're liable to see? And so with that, I'll close, and any other questions are welcome. Thanks. Yeah, shoot.
A few slides back, you showed that there was probably going to be increase in noxious weeds in fields.
Well, now, yeah, bear with me. Yeah, there we go.
Okay. So, oh, by the way, would you repeat my question?
Yes, yeah. The question was, thank you. No, the question was that I suggested there would be an increase in noxious plant species in fields, weeds, and
And would you say why?
essentially, and the question is, why would there be an increase in these species? And that is because basically it's a more favorable habitat for them if the climate changes. If it is more humid, let's say, in the summertime and maybe not as cold in wintertime, my guess is that, and this is a pure guess, is that the yellow star thistle that was so prevalent around Sacramento, California, where I grew up, is getting a toehold here because maybe it's just not getting frozen out in the wintertime as much. But that's pure speculation. It's just that we are seeing migrations in animal species and kind of changes in plant species slowly, but they're occurring. So, a question.
Yes. Can you add fungus species to the invasive list?
Well, should fungus species be in the invasive list, and I kind of lump them in with pathogens. But yeah, I think that has been seen. There's one thing, for example, there's a little, what is it, a fruit fly that preys on berries that is moving up from the south. Some of the commercial growers are starting to worry about that because they get inside the berry and just kind of turn it to mush. And it's a Drosophila, yeah. And so, we're seeing that sort of thing, and I suspect some of the speakers will have some. Any questions? Yes.
How do you, this climate is such a long-term kind of thing, and so there's these longer cycles. There might even be ones that we don't even know because we haven't recorded weather long enough. So how do you count that in there when you're kind of looking at climate change? Do you kind of moderate certain things by part of it's to be expected and part of it's, so how do you kind of separate that out?
Yeah, the question was about the kind of long-term variations in climate change and how we're trying to account for them. And that's a challenging part that we're still working on. We are familiar with and understand some of those having to do with changes in the orbital cycles on kind of tens of thousands, 100,000 year time scales. 100,000 years, we can't really deal with that or plan for that. The more insidious ones are the ones that are kind of multi-decadal time scales. And an example there is one having to do with the ocean circulation in the Atlantic. And that seems to have a really long cycle of 50 to 100 years or so. And so how we can deal with that may be at least partially responsible for why we haven't seen the globe as a whole warm quite as much in the last decade or so, is because of those kind of cycles. So we're trying, and that's all I can say. Yeah, but we're certainly not perfectly accounting for those. Any other questions? Well, I just want to say I applaud you for coming here and being interested in this topic enough to kind of learn more about it. This is the first step, and so again, I appreciate your interest, and thanks a lot.
Thank you, Nick. So we are seeing, to summarize just a couple of points before moving on to our next presentation, more hot days in our summers. We're expecting to see more hot days. We're expecting to become more humid, and that's going to have some implications for us on the west side and the east side of the Cascades, and that we are probably going to see wetter winters, drier summers, less precipitation in the form of snow having an impact on our summer water patterns, which has implications not only for us in terms of our own water use, but other organisms that live in water, like salmon. New stuff for me, I don't know about you, I'm not well read in meteorology, so heat index and the stabilization wedge, that's all interesting stuff. What I want to say is that Nick's presentation for those of you who didn't catch every detail. Excuse me.
And if I could say one more thing. As Brady said, I'm your state climatologist. Woohoo, right? But if you Google the Office of the Washington State Climatologist, you can find us easy enough. And if you have any follow-up questions, we're there for you. And we're happy to, dig out climate data if that's something you're interested in, or just, some other topic. So don't hesitate. I'm pretty easy to find online. And again, I'm interested in what you guys are interested in. So thank you.
Okay, and we're going to have a microphone for the audience. For those people who are watching remotely, we're going to get all this technical stuff together. It's our first time, bear with us. Okay, our next speaker is Chad Kruger. And Chad is the director of the Washington State University Center for Sustaining Agriculture and Natural Resources, where he oversees the center's research and university extension efforts that range from organic farming and to climate change and working on small farms. He also leads the center's award-winning program, Climate Friendly Farming. Please join me in welcoming Chad Kruger.
We'll be right about here, right?
We're, if you could just step over a little
A
bit
little
more.
bit closer.
Right, about a little more, right there.
Okay, I'm going to try not to move, which is impossible. So, just a kind of quick note before I start that climate change in horses is actually more than just a scientific interest for me, because I am a horse owner and come from a ranch in eastern Washington, and so I really do enjoy horses. It's about the only thing that keeps me sane. But what I'm going to try to do today is give a sense of explain principles using the results that we've got. Another thing I want to talk about, and you'll note that this is actually from Nick's group. Nick's website is really cool. There's a lot of really cool tools on Nick's website, and so go to his website if you have any questions. You can manipulate data and play around with some things. But I want to point out something really important here, and Nick was covering this, and he even mentioned that this issue of climate variability is probably a really strong signal for several decades yet. And when we've looked at our results from the perspective of trying to project climate change impacts on production ag, the reality is, at least out to mid-century, this current set of, high variability, interannual variability for a lot of different reasons, including the El Nino, La Nina cycle, is probably a stronger signal than climate. The relative yield differentials that we've historically experienced on a year-to-year basis are actually on the order of magnitude of what we projected for changes for most crops out to mid-century and a little bit beyond. And so what that tells you is, well, there's two things there. One is that the year-to-year variability we already deal with is a difficult enough proposition to manage, that even though we are going to see changes, and by the end of century those changes start to get, the envelope of or potential gets much bigger, they're still going to be fairly muted, at least in our region. In some of the other regions of the world, there's real serious problems projected from climate change, just in the very near future. But we seem to be, a relatively insulated region. And, so I want to point this out, that this El Nino factor is a fairly big factor, and then plus weather events. And so the way I'm going to kind of show that is, this is 2009 to 2012 for a number of different crops in the state of Washington coming out of NASS survey data. And there's some anomalies in the NASS survey data that you can't take, don't think that this really just means we had 73% of historic average yield or average yield over the period. There's lots of things going on in this data, but what I want you to kind of just take away from this is, on an average basis, looking at average yields, which we always use as our index, is not necessarily a very helpful thing, because we have a lot of traffic up and down, a lot of noise in our current data. You'll notice in this one that hay is actually, one that we have less noise in. It's kind of less than plus or minus 10%. Question?
Going back to your last slide, did you say that Washington is a place that is sort of insulated from climate change?
No. What I said is, when you look at our yield projections and things like that I'm going to show you, and Nick kind of commented on this, that these types of things that are going on in our climate systems, the interannual variability of the El Nino cycle, when you look at things like this, and some of the El Nino La Nina cycle is embedded in this current pattern may overwhelm the signal of climate change in terms of our ability to tease out the climate change signal. In terms of, Nick said it, in terms of whether or not you observe and feel like the climate's changing. We see the same kind of thing when you look out to yields, that probably until mid-century in our region, at least according to our projections, there's a pretty good chance that it's a muted signal on the climate change trend relative to all the noise that we still have in the system. Does that make sense?
So it won't vary that much?
No, we don't know the answer of whether it will vary that much, and I'll get to that. So let me present a little bit more, and then I'll try and come back and reinforce that. Okay, so I want to kind of give you the spread of what's been done in this research area. So last year, some colleagues and I worked on the Northwest Climate Assessment Ag chapter, and we took what was published research data, only what was published, and kind of broke it up and said, where's the work been done, to try and get a sense of, what do we know, or what work has been done. And so you can see, if you're interested in livestock, this is it. The basic things that have been done in livestock is the effects. And, fruits, nuts, and berries, heat and drought stress, changes in precipitation regime, the CO2 fertilization thing Nick hinted at, and then irrigation water. Those are the, we've really spent the vast majority of our money and effort here on grains, oilseeds, dried beans, fruits, nuts, and berries, and vegetables. That's really where we focused. There is a little bit in terms of other crops and hay, again, the CO2 fertilization benefit and irrigation water. But that kind of gives you a landscape. Most of our effort is here. There's a little bit, tiny bit done here and a little bit done here. And just in the last 3 years, in terms of research that's ongoing that was not included in this because it wasn't published yet, we've done quite a bit more there. And that's what I'm going to show you today. Another way to look at this, and we can actually provide you the link and you can go read this chapter if you really want to dig into this. You know, there's lots of drivers that are climatic, lots of possible effects. And this is some of it. So here's 2 studies. Cynthia Rosenzweig in 1996 and short term, so that's 25 to 30. Intermediates, mid-century, long term is late century. And you can see everywhere from basically 0% change to negative 33% change in potato production. And what the point I'm going to try and make here is when you look at these projections, you can't just look at the number that's presented and say, oh, that's what this means. You know what they locations. They may have had, any number of different assumptions that they made when they ran that projection and published that result. So you can't look at one projection. You have to look at multiple projections, and you have to understand what was being projected. And the other thing, and I won't do it so much today, but I've done some other presentations where I've kind of showed the evolution of the science in this area and how we're thinking about it and how much more sophisticated we are in terms of what we're projecting now than we were when Cynthia did this work in '96. And there's been a lot of change. We're getting more and more precise, and I wouldn't say we're super precise yet, but what you're tending to see is, these kinds of results that Cynthia projected are tending to shrink. Whether they're positive results or negative, whether they're above the axis or below the axis, they're tending to be confined a little bit more the more sophisticated of the work that we do. And to kind of explain that, when you run an experiment in the field, what you're doing is you're trying to hold as many things constant as possible and manipulate one factor to see what's the effect of that one factor on the result. When you run a model simulation, you're doing the same thing, but what you're able to do in a model simulation is manipulate more factors. And so what happened is those early studies is they basically held lots of things constant and manipulated one factor and didn't necessarily control for all the other factors as well. And as the science evolves, we're doing a better and better job of that. Okay, so when we talk about the CO2 issue, because it's a super critical issue. We can't just look at changes in temperature, we can't just look at changes in precipitation and understand the effect on plants, because there's this other really big driver in how plants work. And this is the emissions scenario, and this is old stuff. Nick showed some newer stuff out of newer IPCC studies. But basically, we're going to project emissions going forward that continue to rise. We're around 400 parts per million in the atmosphere now, and that's continuing to go up. And depending on decisions that we make as a society, it may go up like this, it may go up like this, but it's going to continue to go up for quite a while. CO2 concentration in the atmosphere matters to plants in more than just kind of the indirect effects it has on temperature and the larger climate system. And that is because CO2 goes into the plant along with sunlight and is converted to sugar and oxygen. So CO2 is the input for plant production. And the more CO2 you have in the atmosphere, it acts like a fertilizer. So the more CO2 that's available, the easier that the plant can grab it, the more efficient the plant becomes in using water to produce biomass. And different plants work differently. So two of the major types of plants that we have are what we call the C4 photosynthetic pathway and the C3 photosynthetic pathway. What you really need to understand there is C4 is more efficient currently. It's, from an evolutionary standpoint, it's more evolved, more efficient, and really is not going to get much benefit from elevating levels of CO2. So the basic plant that we think about from a crop production standpoint that is a C4 plant is corn. And so looking at changes in CO2 concentration and looking at corn in two different locations, it just doesn't get a whole lot of benefit from that elevated CO2. The flip side is wheat is a C3 plant, and most of the crops we grow, most of the forages we grow are C3 plants, and therefore as the CO2 elevation increases, they're going to get a much greater boost in terms of productivity from that elevated CO2, and you'll see how that plays out in some results. Okay, so let's look specifically at the published research on livestock production in the Pacific Northwest. That CO2 enrichment factor that I just talked about, it may increase yield, but it is likely, at least in this one study, to decrease forage quality, particularly when things dry out. Why is that? Could be lots of reasons. Some of those may be, biochemical, physiological aspects in the plant. Some of this, I suspect, is actually just a nutrient dilution effect. So if you hold constant the amount of water and the amount of fertilizer or fertility in the soil, and you increase CO2, you're going to increase biomass, but you still have the same amount of nutrients, and it's just going to get just diluted in the plant. We see this. I mean, this is a historical thing that's happened in, as we doubled our wheat production, we see certain nutrient concentrations in wheat have gone down. Okay? And that happens, across the board. You can manipulate some of that, increase your nutrient concentrations and get that back up, but not all the way. So I think some of that is probably just a nutrient dilution effect, but there may actually be some biochemical or plant physiological factors going on that are affecting that. Doubling CO2, reduced dairy cow yields as measured in, and you showed this, by 0.1 to 0.2% for our region. Not a whole lot. Dairy losses attributable to heat stress, much more significant. Nick showed some of that. There's some more work coming out of some of our other colleagues. And forage productivity increases. So those are kind of the principles that are in the literature right now. A couple of things. Now, here's some projections, early projections for alfalfa production. Again, you got to look at where these were done and what were the assumptions. California, specific to the Columbia Basin in Washington. One that just said the Northwest but didn't really talk about where. We don't know if this was averaged across the region. And kind of all over the board in terms of projections, near, intermediate, long term about what would happen. Different climate models, different assumptions. You really got to be careful what you're looking at. One kind of interesting thing here is for this case, they're all above the line. They all tend to be positive. Okay, so now let's get to some of our work, and this is the most recent work it's actually in preparation for publication. We did this work, we started this work by working for the Department of Ecology, looking at doing a Columbia River supply and demand forecast for the 2030s. Now, the big question is climate going to affect irrigation water supply and water for in-stream demands like fish? And so what we did is we actually modeled 40 crops in spatially and temporally distributed throughout the Columbia Basin. And that's actually a first, and I'll show you some maps of what we've done. But you see a couple of things here. The first thing you see is these are irrigated crops and these are dryland crops. And the potential changes in the dryland crops are quite a bit more significant than the potential changes in the irrigated crops. And that's simply because irrigation, having a full water allocation, mutes some of the impact of the climate. We already see this. The one place where you can say crop production, interannual variability really tracks well with El Nino, La Nina is the dryland crops. Because the big factor that El Nino, La Nina does is it's how much precipitation did you get. Whereas in the irrigated system, if we're irrigating, we're kind of intentionally doing that. Question?
These yield changes just look at CO2, or do it include temperature maps?
Yeah, I'll actually show you what we've got laid out here. And so I'm going to let's take grass hay, because we've got it in irrigated and dryland. What we've done here is we've actually teased out those different factors for you. So blue is precipitation only, red is temperature only, yellow is precip and temperature together, the other red is CO2 only. The light green is climate, precipitation, temperature, and CO2 together. And then the dark green is climate, CO2, and this thing we call crop mix. And this is a really important one, and this was a very simplistic approach to do this. And the idea behind crop mix is farmers are smart. And if conditions change, whether those are climate conditions or market conditions, we should be expecting that farmers will do what they can to adapt to those changes. We already see this. If we projected 30 years ago what was going to happen today and didn't project the amount of wine grape production in the region, we'd be kind of silly, right? But that's essentially what we've done with virtually all the prior projections, is we've just assumed everything's going to be static and farmers would continue to do the same things regardless of changes going on around them. So in this study, we actually try to say, no. We think farmers will react kind of endogenously to the changes that are presented to them and try to give kind of a fudge factor for that. But it was a simplistic interpretation. It wasn't very complicated or very, serious. This was just kind of what you might expect in terms of changes in which crops were grown. And so what we tend to see is, temperature on grass hay may have a slightly reducing effect in yield. Precipitation has a fairly substantial increase in yield in dryland, but nothing, of course, in irrigate, because we irrigate. You put the two together, and that precipitation effect in dryland is actually quite substantive. And it's still kind of really marginal in the irrigated system because water, we substitute the water. The CO2 factor on alfalfa grass hay, Timothy, is a fairly prominent boosting factor, at least for this study. And this, of course, is in the 2030s, so this is kind of near-term looking. And then when we add that crop mix factor, basically everything looks pretty good for the hay crops. Now, there's some caveats to that I'll get to, but realistically speaking, it's probably generally positive but modest. And when I say modest, look, plus or minus 10% difference, plus or minus 10%, maybe a little bit higher for the grass hay and dryland alfalfa. But that's within the realm of magnitude that we already see in annual yield variability. And that's kind of why I'm saying, projecting forward to mid-century, this interannual yield variability that we already experience is probably a stronger signal than the climate change signal, at least to mid-century. Does that help further reinforce that question? Okay, so here's another way to look at what we projected. So historical yields for alfalfa based on where we actually have produced alfalfa historically. This is out of the USDA National Land Cover Database, or in our case, it's actually Washington State Department of Ag has made that database more precise. Future yield under irrigated conditions, slightly different, slightly better in terms of the percent or tons per acre. Percent change, over the past is, marginally better for a lot of it, a little bit more than marginally better for some of it. And you can see it. One really important thing here is location matters. Location matters a lot. So when you see the earlier numbers where, one published report put a single number for the entire state, the entire region, this puts a little bit more boundary on that where you're at in the state actually matters.
And that assumes that there's enough water to irrigate.
Yes, and I'll get to that. Non-irrigated alfalfa, actually quite a bit greater changes where it's dry land and coming back down to here, 10%, upwards of 30%. So you can see that location again matters here, and this one was largely, remember, driven by precipitation. Okay, what I just presented to you, was there's another caveat to that. It was one climate model, kind of an average-ish climate model projection. But we know that that's not a realistic way to do it, because how did we know that one was right? Most of the prior studies have been 1 or 2 or 3 and averaged and presented. That's the data. But we know that, if you look at 30 climate projections, the spread is huge. They're all relatively positive on temperature. They're somewhat mixed on precip, but the patterns that Nick told this morning are basically it. But if you look at any one of them, it could be fairly different. So here's 5. And these 5 kind of run the bracket, center, really low, really high, and in between. And you'll notice that the temperature on the minimum or maximum and minimum are relatively close to each other, but that the precipitation projections from those different models are very, very, very widely spread. So let's look at that data set again. Only we're going to see something different. I'm not showing all the different pieces of it. This time we've taken 4 of those and plotted them. This green bar is the same green bar from 2 prior slides. So it's that whole package of different conditions together. What these others are is just taking the different climate model and doing the same thing. And so, here's an example. The obvious one that's really kind of crazy is this winter wheat in the dryland system that, depending on which one of those projections you use, could be anywhere from 20% yield increase to almost 80% yield increase. Now you come down to the hays and you're more on the range of 10 to 40% yield increase. Now, I'm going to say something right here. Don't take the 8% or 17% and put gospel truth to that. What you're looking at is kind of the relative magnitude of change and whether it's positive or negative. You can't do a whole lot more than that with these results at this time. But the story is kind of there. At least looking at an intermediate projection, looking at a number of different projections, it looks like for the hay crops and most of our other crops, which are C3 crops, the general story looks moderately positive with a lot of caveats. Okay, so we started to tease at this thing with the CO2 effect and trying to really tease that out, because what we start to see when we get to the end of century projections is that CO2 effect starts to change. It's not necessarily a linear effect. And what this chart shows is a really busy chart, but basically what it shows is that when you put the CO2 gradient, increasing elevation of CO2 against temperature gradients for different crops, corn, winter wheat, potato, and alfalfa, it is not a linear effect. If it was a linear effect, you would see basically a straight line through every one of these, and you don't see that. So some crops may benefit from that CO2 effect differentially over time relative to other crops. We know that corn doesn't get as much of a benefit from CO2, but it looks like in this case we project that alfalfa will get a better benefit for longer than even wheat. Okay? So that's this is a new one, just literally just hot off the press and moving forward in publication. But it's kind of an interesting thing to say, we've kind of known that CO2 effect is a big deal, particularly near to mid-century, but that the long-term look of it is somewhat more mixed and may very well depend on the crop. Okay, so let's go to your question about whether or not there's irrigation. So again, this green bar is the same green bar you've seen before. It's kind of our aggregated picture, and this is just irrigated crops. The yellow bar is historically what has happened to crop yields, relatively speaking, when irrigation was curtailed. So we don't have enough irrigation water. If you're in the Yakima and you produce, you're a junior water rights holder, you're going to get pro-rationed. If you're in some other parts of the state and you're a junior water rights holder, you're just going to get shut off. And historically, that's been a big deal, whereas depending on which crop you grow, anywhere from 20 to 50% yield reductions for the state. Okay? What's really fascinating here is you overlay the future water supply, which we've projected, and this again is the 2030s, and even though we project less total water for irrigation, or there's a little bit more total water, but less in terms of the timing it's available, we project more curtailment. We actually are also projecting slightly less than historical impact on yield. Kind of a counterintuitive thing. What's the driver for that? Anybody guess?
More efficient use of water to the higher level carbon.
CO2. Now, here's another question though. This is just a single projection. What if we go from a situation where currently, if you're in the Yakima, you you're prorated once every 5 years to now you're prorated every other year. Okay, so you got to kind of overlay how often does this happen and what's the effect. Okay, so again, geography matters. If you're in the Columbia Basin on project water and this is not a concern to you because you're going to get your full allocation no matter what. If you're in Yakima or some of the Walla Walla area or the Okanagan area and you are a hay producer and a junior water break producer, you're already getting curtailed frequently. Question?
How does that determine the junior water rights?
Okay, so without going into a lot of detail.
Repeat the question, please.
Okay, so the question is how are junior water rights determined? Without going into a lot of detail, Western water law has two factors. First in time, first in right. If you were there and had the water right first, you were a senior water right holder, and anybody who came after you is junior to you. If there's not enough water, you get it, and anybody after you who's junior doesn't get it. Second one is use it or lose it. If you have a water right and it's 4 feet per acre per year and you only need 3 feet per acre per year, if you don't use 4 feet per acre per year, you lose it. Okay? So we've got some very strong property rights law that dictates, and particularly in places like the Yakima, the Okanagan, the Walla Walla southeast corner, where there isn't enough water on in some years either to meet in-stream demands that are legal for fish or just simply run out of water, then junior water rights holders will get either curtailed, prorated, or cut off depending on the situation in their watershed. Yakima is the only watershed in our state that's adjudicated. So all the others, they just get shut off, and it can be kind of a serious deal. But so looking at curtailment versus climate for pasture and alfalfa, the yield due to curtailment, in that 10% range. And again, we produce a lot of alfalfa right here, and you just don't see anything showing up on the map because they have no water no matter what. Whereas if you produce alfalfa, in the Ellensburg area, and you're junior, you're going to lose some yield. Climate, again, much more mixed. We see a lot more of our, Columbia Basin alfalfa producers right there having some moderate effect on climate. Okay, so what are we ignoring in these projections? Extreme events. This is what I want Nick and all his colleagues to really sort out and figure out for us and give us some projections on everything from flooding to heat stress to timing of hard freezes and frosts and all these other crazy variables that actually affect production. Because those are the things that really matter. It's not so much that average trend that gives us a problem, it's the bad year. And the bad year, depending on the crop, can be caused by a number of different climatic factors, and we simply at this time don't have a good sense of what those impacts might be. And so this is kind of a new area that a lot of work is being done in the climatology area, and we need that in order to project anything and to really start to get precise and say, yeah, we know this climate thing is kind of like we think it is now, or no, there's much more serious ramifications. Incidence and severity of weeds, diseases, and insect pests. We've largely ignored this. We've done a couple of studies on insects and diseases, and insects, the basic trend is you're going to deal with more insects. Diseases, it's a real mixed bag because diseases are fairly sensitive to both highs and lows of temperature, humidity, and all these other factors. Weeds I'll talk about in a minute. It's really difficult to take these kinds of issues and overlay those on our current crop modeling approach. It's just a very complicated type of science. And we're starting to do that in one of our big projects. We're looking at a couple of these, some issues of downy brome in wheat production systems and issues of an insect vector disease to wheat production, and trying to actually put those together from the crop protection side to the crop modeling side. But it's pretty complicated. Technological advances, we've largely, other than that crop mix factor, or saying that farmers are smart and are going to make some obvious adjustments, we've largely ignored this. And if you look historically, we can't ignore this. That a lot of the gains in productivity, the gains in efficiency have come from technological advances. Even if you just look at an organic system, and people tend to think of organic as, not necessarily using all the available technology, our yields in organic have come up drastically relative to conventional yields because of the implementation of better knowledge, better management, and more technology in organic systems. So we can't ignore the importance of technology in forecasting 20, 40, 60, 80 years out on crop production. Because, and I'll throw this out. When we did a survey of wheat producers in the region and said, what do you think we should prioritize in terms of adaptation to climate change research? They told us breeding, 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 breeding. You're going to breed us out of this problem. And you look at that and you say, well, that's kind of, maybe not necessarily the most comprehensive approach, but the reality is breeding has bred them out of most of the problems that they've dealt with. Changing global markets. I've given you a pretty good story here this morning about what our scenario looks like in this region. But if you look at forecasts that have been done for yields throughout most of the rest of the world, they don't look good. They look, in some cases, moderately bad to really bad, even on the short and intermediate kind of time frame. That's going to have some pretty significant impacts on what happens in the global marketplace for commodities. And think about this, something like 90% of what we produce in Washington State leaves the state. And we are a dramatically export-oriented agricultural system, in spite of all the good things we've done about building local and regional. And if you think about the hay market is largely dictated by an export market. Okay? So, and we already see that kind of thing where what happens in terms of crop mix changes in the Columbia Basin or in the Yakima Valley affects the hay market in terms of how many acres are allocated to production and who gets it first. They pay more in Japan than we're willing to pay here to keep it here. Okay, and then the last thing we've kind of really ignored is this thing called the human dimension of adaptation, both endogenous, the things that are obviously they're going to happen no matter what, and then also strategically planned. And we're just starting to tease at, trying to figure out how do we even approach this question, looking at projecting climate and agriculture moving forward. Okay, so now I'm going to talk about that weed thing. And you've seen this chart before. Corn and wheat. Corn and wheat. Most of our current noxious weeds are C4 weeds. They're the highly evolutionary advanced weeds that do a really good job of efficiently using what water is there, and when it warms up in June and July, they take off and compete, and it's really hard to get control of them. They kind of look like weeds or corn. Knee high on the 4th of July, way over your head 2 weeks later, right? That's what we see with our noxious weed species, and this is the one that I deal with every year, and it's getting the better of me. As we move forward, and the increase in concentration of CO2, just like with wheat getting a benefit, the C3 weeds, the ones that largely we have control on these weed species currently, are going to gain that same competitive advantage as wheat. So downy brome, one that doesn't really bother me right now where I'm at, is going to get more and more, well, I should say that. It doesn't bother me where I keep my horses. It bothers our family where we keep our cows. But, this is potentially going to become much more of a noxious weed species. Now, here's the other thing. If you're good at managing weeds already, you're probably going to be good at managing weeds in the future. If you're bad at managing weeds right now, you're going to have more problems in the future because you're going to see some differences. This is still going to be a really noxious weed. It'll just be more of these will be problems too. Okay? So you can't just say the climate driver or the CO2 driver is going to make weeds worse. You have to actually say, how do you overlay management on top of that? Okay, a couple other quick things. There are some things that we can do. We're looking at, I mentioned that the issue of water law. We tend to irrigate to our full allotment, even though we know that cutting irrigation in a lot of crops and being more precise with how we irrigate might actually increase our yields. And yet we do this because all the incentives are kind of against doing what's smartest. And as we sort out some of those incentives and some of the frameworks and enable producers to actually look at this and say, you know, if I were to put this water back in the system, maybe I could get some income from that decision, and I might increase my yields overall. So this is something that needs to be looked at. Question?
Maybe I missed it. Sorry. But why is cutting our water going to increase yields?
It depends on the crop, but this is kind of a very traditional crop water use function. And what we see is, in a lot of cases, we actually use more water than the plant really needs. Now, Nick mentioned something this morning that as ET increases, maybe we'll use more water, and we've seen that. But for a number of crops that we grow, we're kind of here on the curve, or we're somewhere in here on the curve, and it actually could be pulled back quite a bit. There's also the factor that there's a difference between what is, you know, yield potential versus optimum yield from an economic perspective. And I think that's what we're really looking at is, if I can make more money here by selling the additional allotment of water and taking a yield hit, that should be what I do if I'm an economically rational person. But right now, for the most part, even if we have economically rational people farming, the system kind of works against them doing what would be most rational for them to do. Okay? So we've got a proposal in to kind of start looking at this and really try and tease out what could it mean for solving some of our water problems in the region. Another one is increasing soil organic matter, and so we'll talk a little bit about, you know, that this afternoon. We've got some really good examples of farmers in the Columbia Basin that deal with this issue where there are times in July and August where it just flat out gets too hot for too long, and Nick's telling us that's going to get worse. And if it gets too hot for too long, in spite of how advanced and how efficient center pivot irrigation or other types of irrigation are, there are days where you dry out because more evaporates or transpires than you can deliver. And if you're on a sandy soil with 0.6% organic matter, you're going to dry out. You produce potatoes or any other crop, it's going to hurt. And we see this already. Well, Dale Geese, you know, this farmer has, you know, figured out this system where he's using a mustard cover crop, and he's more than doubled his organic matter over the last 15 years. And what it shows, then this is kind of the interesting thing, 30% more water holding capacity. He weathers these events better than others and is one of our top tier potato producers in the state. Question?
So with the increased radiation from the sun that's predicted and the water use, I always question about time of day water use in relationship to the radiation. And is that a big factor? And can we look at that?
It might be on this side of the state. Over here, it's not. Over here, those pivots are running 24/7 to keep up. And then even so, they still don't keep up. And if they shut them down, they'd be behind that much further. Because, you know, the difference between potential evapotranspiration and the actual water that would be there, you know, it's 10% of PET that would be there naturally. And so, you know, they're filling up 90% of that bar, and a lot of that is July and August that they're filling that water bar window. And so they're running 24/7 for weeks at a time to keep up. Here's another one. So instead of, you know, using a cover crop, Jim Baird here planted grass. You know, he had a field that was just, he felt, you know, something's got to change in what's going on here. So he planted a forage species that was just a really high carbon producing species. You can kind of see as he tilled it down and dug it up, you know, tremendous amount of soil organic matter change. Some of this will go away, you know, as he moves back into row cropping. But this is the kind of thing that could happen in a perennial system or a forage system, where forage systems are going to help with carbon, particularly under irrigation, where you really maximize the biomass that's being produced. Kind of another really interesting one that was done a few years ago. This is the Palouse Conservation Farm. It's a wheat farm near Pullman, one of our research farms. And what we did in this study is we compared a conventionally tilled system to a no-till system where the residues were left in place, and what happened to water that fell as snow. In that conventionally tilled system, the snow that fell up here, just basically that water just flowed down to the bottom. And a lot of that water flowed out the drain tile. In the no-till system, the snow that fell here, because there were residues there to hold it, that snow actually melted and went into the soil there. What did that mean? Well, depending on the part of the field that you were in, anywhere from 3 to 13 additional bushels per acre produced on the field. 10%, 5 to 15% kind of increase, or you could look at it another way and say, basically 5 to 15% resiliency factor just from thinking differently about your management. We kind of see that management, kind of intelligent conservation approaches to management may be worth that 5 to 15% resiliency factor, which, again, most of what I've presented says, we're probably in that 5 to 10% factor on the projected changes, at least mid-century. Okay, comment on Savory, just real quickly, we'll talk about this afternoon. How do different grazing systems affect rangeland ecosystems, particularly things like carbon in soils and resiliency to climate? I'm going to tell you this afternoon that, I'm a fairly well-known critic of Allan for the lack of empirical data to support what he's trying to promote. And there is a lack. In fact, there was another paper published just last week that says, there's just not a lot of evidence to support whether he's right or whether he's wrong. And I've got Morris Robinette, cow-calf producer, who's on our advisory committee. He's pushed us for years to say, well, what can we do to actually start investigating this? And Allan will talk about some concerns he has about whether experimental science will ever be able to prove what he's done. And we've taken a different tack. We actually have a PhD student right now who got really excited about this issue and is going to model, kind of like we've shown modeling results for all these other things, he's going to try and model a grazing system and then use manipulations that might be similar to the kinds of manipulations that Allan Savory's talking about, and see, can we see whether or not there's actually an impact on carbon? Can we see whether it matters from the point of view of resiliency to a changing climate? We're not going to be real precise with this, especially on this first dissertation, but the idea is let's start here, and then what that might help us do is help us point to some places where we do need a better experimental data set to help us calibrate what we're doing and really trying to understand this. So it's kind of a new thing. This hasn't been done a whole lot, and it's happening here in your region with a student from your land grant. Okay, so I'll end with this, that climate change will add another layer of complexity and uncertainty onto a system that is already exceedingly difficult to manage on a sustainable basis. Okay, and I think that's really the story. And this is from Stella Coakley from Oregon State. She's an entomologist. Where is she? Climatologist? I can't remember. Anyway, she's done a lot of this work. That was her conclusion 15 years ago. And after all the additional work that we've done, that's kind of our conclusion today is, this is a complicated thing that we have in agriculture to manage sustainably. And climate just kind of one more straw or 2 or 3 or 4 more straws on the horse's back. Okay? All right. Acknowledgements, a lot of this was funded by USDA and NSF and Department of Ecology. And if you want more, at any point in time, go to our center's page, go to our Facebook page. We have a blog where we try and do some of this, take some of the science we've done and make it more practical and understandable. And we're working on this interface called agclimate.net, where we're going to try and actually focus on climate change and ag research and help interpret that for the average person. Okay. Questions?
So Chad, I had a question related to the water rights stuff. Working for King County, even here we have a lot of water right issues, even though we think we have a lot of water. And so the State Department of Ecology, which handles all the water rights stuff, I know that they tried to work on some certain things, but they're completely overwhelmed with the system. Have you guys started a dialogue, or where are they in the process? Because we're going to have to probably work as a big team and, arm in arm to try to, help them figure this out. I'm just or how we can do that.
Okay, so I'm much more personally familiar with what's going on east of the mountains. And there's some reasons for that. Our forecast study was east of the mountains. The legislature has charged the Department of Ecology, the Office of Columbia River, to do that forecast every 5 years and to invest in water security. So we have legislative charge, we have $200 million worth of bonding authority from the legislature to focus on solving what are really long-term historical water problems in eastern Washington. Western Washington, I know there's a lot of similar kinds of concerns and issues, but simply because there hasn't been the legislative mandate in the same way and the resources put into it, we just haven't worked over here as much. The other thing, and I mentioned this earlier, we could do these same kinds of studies on the west side, but we have an issue of scale. So the scale issue, every grid cell that you were seeing there was 6 kilometers. And within a grid cell, we make decisions about partitioning and which crops are grown in that 6 kilometer block. You come west to the west side, there's cases where a 6 kilometer block would overwhelm the river valley where agriculture is happening. So the tools that we built, which are really kind of more crude scale, large watershed tools, wouldn't be very applicable, and I wouldn't trust any results that we got out of them if we looked at the west side of them. So we're working on another tool in the BioEarth project that you've seen the logo on, that is actually more of a very small scale, catchment scale up type of tool, but we're 3 or 4 years away from having that tool ready to play.
Thank you. Nick mentioned that for Western Washington, we're in this forecast of having sticky nights, more humidity during the day, during the evening. And I know last year we had a couple of days where it was like, wow, are we in the East Coast or what? And my question has to do with how our plants here, our C3 plants, cool season grasses, pasture grasses, although we're forecasted to be drier, hotter in the summer, does that increased humidity, and I can kind of translate that into increased water in the air, which will mean increased amount of dew on the morning. I know in some places it will mean increased fog in the low-lying areas throughout the summer. Does that increased amount of moisture that's either collecting on dew or in fogs, is that going to translate into, and even though it's hotter, there's more moisture, so might that counteract some of the fact that we're going to be drier in the summer, but we may have more moisture available for forage growth on pasture hay crops?
We haven't looked at that question specifically. My conjecture would be there may be a very short window of the year that matters, a few days, that you might get on the margin a little bit more benefit or that kind of thing over a few days. But we rapidly we've run out of moisture. And that's really stark in eastern Washington, much less so on the west side, but it happens here too. So for in the last 3 weeks, this winter, I've gone from it was wet 3 weeks ago to I was in 2 inches of dust to at least holding the dust down again. And it's really stark when you see it in that context, but that's the same thing that's happening over here. The factor that I think might be much more important in terms of effects on yield or productivity is what does that change in humidity and temperatures do for exacerbating disease or benefiting disease? Because we've seen that where we've modeled powdery mildews in cherries and grapes, that the interaction between changes in temperature and humidity that are projected have everything to do whether your incidence and severity go up or down. And it's a mixed bag for the plant diseases, and those were plant diseases, not soil-borne diseases that affect plants.
So Chad, I want to ask everybody if they would like to continue to ask questions as a group and take a shorter break, or find Chad during the break to ask some questions. Any preference? Take a break? Okay. Okay, we're going to come back at 10:30, which is in 10 minutes. And I just want to just very quickly excuse me. Just regroup on this last presentation from Chad. Just the messages that I was sort of taking away from the conversation, is that this interannual variability in yield is something that is creating, we just have sort of some confounding factors, and we aren't really going to be able to, for a while, probably get a handle on how climate change may be also affecting yield. And so we're going to have to just sort of, but the good news is that hay and alfalfa, which you guys are all using for your horses, is looking a little bit like maybe not being impacted too much right now.
With all the caveats.
With all those, I forgot that, right, with the caveats. So on that note, let's take a break. I'm sorry.
I'm sorry.
Question?
Yeah, but adding on to that.
Just turn it on there. Just bottom.
But adding on to that,
Can you hear me? Okay. But adding on to that, you were saying that exporting is going to increase, so we're talking about higher prices, even though the yield is going to increase.
Right, so then there's some competition in the market for you. You're competing for something at a higher, potentially a more expensive level.
Well, the other thing too is I understood that nutrition is decreasing even though productivity is increasing.
I'm sorry.
Is that correct? Nutrition is decreasing and even when productivity is increasing, so you're going to have to feed more.
The few studies that have looked at that indicate that's a concern. But I don't think anything's been done to look at, is that a mitigatable effect? And one more comment to your comment is, I actually just wrote a blog post that should get posted either late this week or next week that looks at some of these climatic factors that affect productivity of crops and how muted the effect is for consumer purchasing of food. There's a huge disconnect there. And that disconnect both goes from the fact that, farmers see this and consumers see this. But for purchasers of forage, that farmers see this, but consumers of forages see this. And we've seen that factor affect dairy farms as, markets get tighter. The price of feed on the dairies just goes way up, much more than the variability that producers of the feed see.
Okay, so I'm going to suggest that we take an extra 5 minutes, cut our break from 15 to 10, and come back at 10:35 to hear our next presenter. Thank you.
No, I'm the last one.
What we looked at is a very similar story in terms
Yeah.
when you look at those charts and you say 6% increase, 14% increase.
Yeah.
I mean, at 0 to 10.
Thank you for your help.
So
Some signal.
the margin.
We got it to work last time. Yeah, that's so. Who knows? Yeah. How's everything going? Okay, audio's on.
Hello, I'd like to bring everybody back for our next presenter. Okay, we're going to begin our last morning presentation. Our presenter for this session is Dr. Gary Muscatello. He is a member of the faculty at the University of Sydney. He is a lecturer in applied animal microbiology and a research supervisor. His area of interests focus on the intersection between climate change and infectious diseases, and some of his research focuses on respiratory biomarkers and infectious diseases in horses, foodborne pathogens of animal origin, detection and epidemiology of pathogens, and on-farm microbiological diagnostic technologies. So I think that for our audience on the internet as well as in the room, I think we all can agree that this will be a very pertinent topic to your area of interest. Please join me in welcoming Dr. Gary Muscatello.
Okay, thanks a lot. In simple terms, what I am is a veterinarian with an interest in infectious diseases of horses, basically. And I think climate change and the impact that climate is going to have on horses' health is a really important thing that we need to be conscious of. In Australia, our climate is harsh enough to start with, that the impacts of climate change are going to be even more severely felt if the predictions are correct. But what I'm going to basically do today is outline this concept that the horses that we keep and whether they're healthy or not is actually a result of horses interacting with environment. And factors in that environment, and some of the significant factors obviously are going to relate to disease prevalence, is whether the pathogens that are responsible for disease are within that environment and how they're actually interacting with our horses. So this idea of horse pathogen environmental interactions or host pathogen environmental interactions, and what sort of factors relate to biases towards either keeping the horse healthy or manifesting disease in the horse is what I'm going to try and get you guys to sort of understand a little bit more about, because it's important that we understand that in relation to how climate change is going to impact upon those interactions and therefore impact upon the risk of disease manifesting in our horses associated with bacteria, viruses, fungal agents and protozoa. And I think the best way of illustrating this is actually through examples that we've gone through in Australia most recently, and also some observations that I've seen in the United States, and some anecdotal evidence of colleagues in the Pacific Northwest that are telling me that they're seeing increasing prevalence of certain diseases that are related to climate change events. And then to finish with trying to give you an idea of how to proactively adapt your environments and what sort of things you need to think about when you're doing that to try and maximise the health of your horses. So this is the classic disease triangle or disease triad that we face with when we're trying to explain disease and why disease occurs. So it's the interaction between our host animal, in this case a horse, the pathogens that potentially can cause disease.
Gary, we're going to have this
So that everybody can see you.
Can you see it? A little more.
You can step forward a little. There, perfect. There you go. Excellent. Thank you so much.
As long as people can see the presentation, it's more important than actually seeing me. So this is the triad of disease, essentially we call this, where the host and its interactions with the pathogen and the environment actually dictates what sort of risk of disease manifestation will be on the host. So our aim as horse managers is for this, for a horse-biased environment or a horse-biased interaction, to promote health and to minimise the potential for pathogens to cause disease. Now, if we have negative impacts upon the horse, this may happen. And therefore we're going to have the pathogens more prominent and interacting with the horse in a negative way in certain environmental settings and causing deleterious effects to the horse's health. So when we understand or we relate this back to horse health, we're really talking about understanding the horse ecosystem and the horse ecosystem making up the environment that the horse is in and all the factors within that environment that are going to impact upon disease risk. So understanding that temperature, land and water availability is going to impact upon the horse, sunlight, atmospheric conditions, feed and nutrition, how we house our horses and general husbandry mechanisms, and the other animals in the environment that may be interacting, horses in their own rights or mob mates, and other animal species that may be interacting in that environment. And then also insects, which are going to be playing a much more important prominence in climate change related disease risk events. And so what we need to be aware of is, of course, what we're really aiming for is good horse husbandry that biases towards in the future. So climate change and risk. The real effects of some of the climate change events and predictions on horse health is that it may have some effects can have some really negative impacts on the interactions that we see between the horse and pathogens in the environment. So just some generalisations of some of the predictions that has already been discussed this morning by other speakers is that in this region, as with a lot of other regions in the world, there's going to be an increase in temperature. And I think one of the more alarming things that I think needs to have a lot more focus put upon it is the fact that there's going to be increases in extreme weather events. And for this part of the world, there's some discussion in various climatology groups that there'll be more extreme rain and storm events, more high likelihood of increased likelihood of flooding events, and potential coastal destruction. And then, as we've heard from speakers this morning, the summers here are going to be drier, drought conditions are going to be more severe, and this consequence of increasing production of herbage and forage may actually result in a lot more, material there that can be set alight, and the intensity or an increased likelihood of more intense wildfires. All those sort of things, along with ozone and greenhouse emissions, are going to lead to declining air quality over time as well. So all those things are going to have an impact upon food and water limitations, increasing stress upon the animal in relation to all these climate change events, and overall potentially reducing the fitness of our animals to deal with pathogens that it may interact with. The other thing is the outside environment and how that's going to impact upon wildlife. This is a really important issue, where we're getting limitations or reduction in natural resources due to climate change events. Where are the wildlife that's on our borders going to try and find food to sustain themselves? Well, they're going to come and look for food across the borders where we're keeping our horses primarily. So this idea of wildlife encroachment being a really significant disease risk we need to be acutely aware of. We've already talked a little bit about, some speakers have talked about the likelihood of increasing concentrations of insects and specific microbes. I'm going to sort of talk to you about some specific pathogens that we're going to need to know a little bit more about and be more aware of in the face of climate change events. And obviously, with an increasing amount of, or a decrease in air quality and an increase in pollutants, how that's going to also impact upon respiratory health, especially for horses. So all these sort of negative impacts we're going to have to try and think about how we can potentially mitigate the impacts of these events on our horses. So these are just examples that we've already sort of seen a little bit about in terms of what's going on with warming, especially in this part of the world. You can see here the increasing temperatures over time over the last 100 years. And again, as Nick mentioned before, in some areas of the United States, the warming is not happening as abruptly, but there definitely is some general trends in high temperatures in this part of the world. And when you look at what's going on with climatic events in the United States, well, you can see, it just depends on where the hell you are, really, there's something going on. So we need to be conscious of that. And especially up here, you have evidence of increasing drought conditions in the west, extreme in carbon monoxide levels associated with fires, water levels decreasing, those sort of things. We need to be conscious of that when that's occurring, and the utilisation from you guys in terms of utilising climatology resources to get some sort of ideas of when these events are particularly going to be a risk or occurring, allows you to do some proactive actions yourself to try and protect your animals from these sort of consequences of these events. So there are a variety of bugs that are going to love climate change, and I think the thing that comes across with a lot of the speakers that have told you about the impacts of climate change is that we're going to have animals that are going to be undergoing extreme stress events in relation to potentially extreme weather events and wildfires, etc. The general warming trend and the general trend for increasing humidity is going to increase the risk of specific infectious diseases. And we've sort of classified them into sort of 4 groups. The first group are these opportunistic pathogens, we've called them. These are things that are bacteria and fungi that are seen in the environment and that replicate usually in soil and water, but they're usually not replicated to high enough concentrations to be of any risk to horses. But as temperatures and humidity increases, those levels of these particular pathogens will increase to levels that could be hazardous to horses. Insects, obviously, a variety of viral pathogens are trafficked by mosquitoes, flies and ticks, and they'll become more and more of an issue for you guys up here in the Pacific Northwest. The issue of wildlife encroachment and the fact that there are a variety of viruses and protozoa and other bacteria that are borne by wildlife, such as migratory birds, opossums, for example, in this area. They're going to bring those pathogens in, and they may be just carrying those organisms in and have no effect themselves. But if they're excreting them into feed, excreting them into paddocks and pastures that are utilised by horses, then those horses will pick up those pathogens, and many of them can be quite deleterious to horses. And then there's a group that probably we don't think too much about, and these are infections that are going to become reactivated due to climate change. So the classic example that we can all relate to is herpes virus in humans, and the same sort of things can occur with animals. And when we're under stress, if you've all had a cold sore before, you'll get reactivation of that cold sore when you're under stress and you're under a lot of pressure. The same thing can occur with herpes viruses in horses, and unfortunately, some of the herpes viruses in horses can cause things like abortions. Now, if that gets reactivated during gestation of a pregnant mare, bang, you've lost your foal. And these events are going to probably occur with increasing frequency because the animals are going to be under more stress, especially in relation to extreme weather events. They're going to probably stimulate these reactivations. So, we're going to sort of, as I said before, I like to sort of go through some examples. So I'm going to try and go through some key examples that we've seen in Australia, and we are relating to how climate change is increasing the risk of certain equine infectious diseases. So the stress of the animal and the reactivation of herpes virus, we sort of talked a little bit about that already. And just the fact that the animal is going to be compromised to more of a degree than it would be otherwise is going to lead to being more susceptible to a variety of opportunistic bacteria and fungi that are going to grow in the environment. There are a variety of drought associated equine pneumonia, which is what I did want to see on and this really nasty phenomenon which we've seen in Australia, and we've also seen in Kentucky in the past associated with caterpillars and abortions in horses that has a definite climate-related event, climate association. Those pathogens are going to be affected or increased in risk in relation to mild and wet periods, which we're going to see more of, I think, with extreme weather events and warming trends and increased humidity. So the insect-borne diseases, West Nile virus, Lyme disease, we'll talk a little bit more about those, and a variety of other opportunistic pathogens, things like, is everyone familiar with the term greasy heel and lane school? We use those terms here for dermatophilus. Become more and more evident in relation to having muddy, wet, humid environments. Wildlife encroachment diseases. Hopefully you're all sort of familiar with Hendra virus in Australia, and that's associated with fruit bats. Again, rabies virus. Not really associated with horses too much, but as an Australian, we had the first case of bat rabies virus transmitted to a horse last year through a biting event. So these sort of things we need to know a little bit more about, because they're going to emerge as significant issues potentially in relation to climate change. And pollutants, you know, the occurrence of heaves and other opportunistic respiratory diseases we need to be acutely aware of as air quality becomes more of an issue. So I'm going to talk a little bit about some of these guys, just a selected few that are probably of interest to you guys as much as interest to us in Australia, because they are likely to be seen potentially, or derivatives may be seen in the future up here. First pathogen I want to talk about is bacteria called Rhodococcus equine. This is a bacteria that is typically found in the soil. It's a saprophyte. It lives happily in the equine environment, and the main reason it does so is because it utilises volatile fatty and grows to quite high numbers in that environment. And during the summer in Australia, virulent strains of this organism basically and are inhaled into the lungs of foals, producing these very nasty abscesses in the lungs of the animal. And colloquially, we use the term rattles to describe this disease, because you can walk into a stable with an animal infected, and basically, because it's struggling to breathe so much, it's basically rattling as it's trying to breathe, because it has all these abscesses associated with bacterial infection that it's trying to combat as it's trying to get air into its lungs. So it's rattling away and causing all sorts of problems. It's a seasonal disease exacerbated by dry and dusty conditions. And if there is any major equine breeding facilities in these sort of regions, they are going to be experiencing more and more cases of Rhodococcus equine pneumonia as we have more severe drought conditions during the summer and spring periods in this part of the world. Other factors that contribute to it, and this is a typical scenario in a lot of the Australian breeding facilities where we've got animals waiting here for veterinarians to examine reproductive viability of some of these mares, and there'll be these foals basically lying in sand and dust for 2 or 3 hours a day, waiting for vets to get around to examining horses. And while they're doing that, just an environment that's perfect for the inhalation of the organism and picking it up through that means. So having an idea that things like the soil composition is going to have an impact on the ability for dust to be generated, and therefore relate to risk is really important in relation to disease. And even the stables that you're keeping these foals in, if you're keeping them indoors, if you're using bedding that's highly fragile, like straw or hay, and that's contaminated with fecal material, it's also likely to be contaminated with the organism. And given that we're getting warmer and drier conditions outside, we're probably going to get warmer and drier humid conditions inside as well. And you're going to have a lot of dust being generated from just walking around in those stables and fragile material breaking up and inhaling that material. I got asked to do a study on Great Caucasus Equine Island, and I thought, what the hell am I doing here? The grass was up to my hips almost, and they were keeping their animals inside for 16 or 18 hours a day because it was too cold to put them outside. And the stables were just chockers full of this organism. Foals as old as almost 11 months, 12 months, were still coming down with our equine environment. It's ridiculous. This tends to be a problem where there are lots and lots of animals on properties. The larger the number of foals or the larger number of horses, the more fecal material on the ground as a source of nutrients for the organism, the more trafficking, the more dust generated, and therefore high prevalence disease. Caterpillar-associated abortions. The idea that hazardous caterpillar hairs are hazardous to horses. This was a concept that I started talking about when mere reproductive loss syndrome was identified in Kentucky about 12 or so years ago, associated with the eastern 10 caterpillars. And everyone in Australia thought I was mad. I was just a mad person talking about caterpillars causing abortions. What are you, some sort of freak? And it wasn't until it actually started occurring in our country people started saying, no. And it's caused by these, what are known as processory caterpillars. And they produce these really hairy caterpillars, and it's actually through researchers done actually in Australia that have actually induced abortions in mares through basically just giving them ingestion of caterpillar hairs and actually seeing the little hairs in the placental tissues and in the fetal tissues of these animals to say that it's actually the hairs themselves that are getting into the bloodstream and bringing with them bacteria that's from the environment causing bacterial infections in the placenta and in the fetus causing abortions. Now, in the United States, when mere reproductive loss syndrome came about, there was an easy cure. And the easy cure was getting rid of the trees that harboured the nests for the eastern caterpillars. And for you guys, it was easy because there was only one species of tree that they liked, these particular cherry trees. In Australia, as you can see by the picture here, this is a nest. This is a eucalyptus tree, and anyone been to Australia knows that there are everywhere. And there are different varieties of eucalyptus trees, and it's just impossible to really try and manage this to any effect, as was done in Kentucky, which basically just revolved around getting rid of a certain tree and therefore getting rid of the potential for the nest to be in the environment that the horse was in. But this is an impossibility for us to do in Australia. And what I also want to do now is also bring in the idea that, hang on, there are we know that there are different species of processory caterpillars that have the same effect. And maybe there are different caterpillar species that could do the same effect in the US as well. It doesn't seem to be something within the hairs themselves that are causing the problem, such as a toxin or something like that. It's just that the hair is enabling the bacteria to get in. Okay? So when this occurs, when these nests are disturbed prematurely in Australia, which usually will happen at the end of summer, during extreme weather events, either storms or wind events. This nest is just full of molted, different stages of caterpillars, basically full of caterpillar hairs in their own right. Okay, that gets disturbed during our summer, late fall, and at that period our mares are probably about 4 months, 5 months gestation. If they got exposed later, when they should get exposed, this will naturally occur in May or June, which is our winter period. our mares are too advanced to have any consequence from the seating. But if this happens prematurely, and then there's wind that carries those seating onto pastures that are grazed by our mares, then they can potentially get infected and cause abortion associated with it. Okay. So, trying to understand that, being able to recognise these nests and trying to avoid mares going into those environments and feeding under those nests specifically. And then understanding how certain tree species are related to these caterpillars and other climate factors relating to nestings we don't know enough about, but are probably important things that we need to know about in terms of trying to control this particular disease. Wildlife encroachment. I think one of the most critical things that people are overlooking with climate change is the fact that natural resources are being limited. We've already limited them ourselves by urban development. Now we're going to have extreme weather events such as wildfires that are going to occur with greater frequency, and they're going to destroy habitats of animals, and they're going to come into our habitat to try and feed and maintain themselves. So as wildlife tries to search for food, water and shelter, they're going to encounter us and our horses. And it's this phenomenon of encroachment that's going to facilitate the transmission of disease from these wild animals into our horse population. And the classic example we had in Australia was these fruit bats pissing onto waterways and pastures that were being ingested by our horses. The urine and excretions were full of hendrovirus, and the animals would pick it up and actually develop hendrovirus, which is a deadly neurological disease impacting upon our horses. So that's a classic example that we have here that we experience in Australia, where we have fruit bats as this reservoir host in various. There are about 7 different species of fruit bats that carry hendrovirus, and they have no consequence to the bats. It doesn't cause neurological disease. They just have it, and they piss it out. Or actually, the other method that they use to get it out, which is probably the most effective method of actually transmitting it to the horses, was that if you can imagine these fruit bats as flying cows, they basically ingest material partially and regurgitate it. And in the process of that, they've got a partially fermented fruit sauce, which goes onto the ground underneath them, and that to a horse is just a dream. It's sugary substance that's come from God. And in the saliva of this stuff is the virus. Okay? And that's probably the most the nicest theory that I have, instead of ingesting weed upon pastures, that I think is causing the transmission of the disease from bats to horses. Effectively in Australia, our policy is that because of the rapid nature of the disease in the animal, the fact that it causes a very severe neurological disease, it causes rapid death. So we've gone to the stage where it's just impossible to try and treat these things, and then we humanely euthanize the animals if they do have an antibody response to hendrovirus, showing that they're being exposed. And it's a zoonotic disease. And the importance for us as humans in relation to this is that the horse is the amplifier. Without the horse, we would never get infection from a bat, because the concentrations of hendrovirus in the bat is not significant enough to facilitate transmission and infection. And when they're actually clinically ill. So we tended to see zoonotic cases with veterinarians that were in close contact with very sick horses at the time, or veterinary nurses that were in close contact. Fortunately, in 2011 and 2010, when we had our most significant sort of outbreak of hendrovirus, the public awareness of the significance of this disease resulted in no humans becoming infected, despite the fact that we had about 20 incidences in Queensland and New South Wales, which is really good. For you guys, I was reading up on this protozoa that causes neurological disease that's associated with these opossums. And I thought this is really interesting, because I remember being up here as a student and seeing all of these opossums running around and causing havoc in various farms. And they're not very pretty looking things, rodents. But they get infected with this protozoa known as sarcocysts, and they excrete these protozoa in their fecal material. And if they go and search for horse feed, which they will, and poo into that horse feed, the horse can pick up this protozoa. And if it ingests it, it will develop neurological disease. Usually it's not too severe, but it does cause weakness and can cause basically a variety of ataxia and wobbling events in these horses. Most of them recover okay, but the fact that this parasite can actually survive in the cells of the horse and become latent, it can actually reactivate even though you think you've cured it. And that can occur up to 2 years later. The other wildlife disease that I think you guys need to be acutely aware of is rabies and the significance of that. Now, I realise in this part of the world, terrestrial rabies is really rare. So most of the rabies you have here is related to bats and insectivore bats, apparently. Now, I would think that would be a relatively low risk for horses to come into contact with. But what I'm reading more and more now is that the types of bats that are carrying rabies are a little bit more expansive than just the insectivore bats. And that if they are these fruit bats, and you have fruit trees in your environment, then maybe those bats are going to come into the environment with your horses. The nice thing about rabies in bats is at least that it causes some sort of neurological bats for them to become sort of ravenous. So they'll horses rather than excreting things on the horses. So that might be something to think about in relation to wildlife encroachment diseases. Mosquitoes, flies and ticks, I think this is a huge issue. Warming conditions, more intense rain events are going to cause insect booms. There will be periods where there are a lot of water around, mild enough temperatures to facilitate mosquitoes and flies to replicate in very high numbers and facilitate a number of infectious diseases being transmitted from horses, from other animals to horses via mosquitoes. Also, the fact that there's the idea of warming trends over winter is going to mean that a lot of these mosquitoes are going to be able to survive in climates that they wouldn't usually be able to survive, such as probably the Pacific Northwest and parts of Canada, that they wouldn't have survived otherwise. And what that basically means is when there is the increased warmth and moisture, then the boom is going to be more significant because it's already got a baseline to work with. So we've already seen changes in distribution of insect-borne diseases in relation to Lyme disease in animals, including horses, a variety of equine encephalitis virus diseases which seem to be changing in distribution over time, and pigeon fever. Is everyone familiar with the term pigeon fever? Associated with insects basically inoculating bacterial agents into the muscles of horses, causing abscesses. And more importantly, because of the increasing number of insects, it's going to enhance the evolution of pathogens. So we saw in Australia the evolution of Kruger virus, which was essentially a non-pathogenic virus related to West Nile virus, from a harmless virus into one that actually caused neurological disease in horses in one season. And you guys got West Nile virus, which is a bad enough virus in its own right, but now my colleagues in Texas are telling me that there are new strains that are more pathogenic and are going to migrate up north and going to cause all sorts of climate change. So even though you've got a vaccine for West Nile virus, and I hope that may or may not be available, I hope it's available to you guys to use to protect your horses, it may not work anymore if the viruses evolve and change enough to be antigenically diverse enough to prohibit the vaccine actually being effective. So this was our arbovirus outbreak. The term arbovirus outbreak, or arbovirus, is just a term that we use to describe any virus that's transmitted by insects. We had this event in Australia in 2011, which was just the perfect climate for mosquitoes to proliferate. We had a relatively warmish summer, and then we had a mild, really wet autumn or fall period and late summer period. And this sort of greenness, especially around the south parts of Australia and blueness, really indicates the amount of rainfall that was falling during December and May, which for you guys is winter, for us is summer and fall. So these rainfall patterns were really enabled mosquito populations to really thrive and facilitated the transmission of not just one, but 3 different viruses that were all significant to horses. In this country, for Kruger virus ever, for Murray Valley encephalitis and Ross River virus, we hadn't seen since 1974 affect horses. Okay. Typically, these viruses are seen up in the tropics, okay? And because we haven't got too many horses up there, it's not really a factor. Migrates down south, where we have our major equine populations, bingo, problems. So, migration of those in relation to not only these, the rainfall event, but actually the tail of a cyclone that impacted upon southeastern Queensland, right here. And the tail brought with it the mosquitoes from up here, down here, and the rain that came with that, all those sort of things. And facilitating the breeding and transmission of the mosquitoes and the viruses that it had. It resulted in basically becoming infected with these viruses. Now, Kruger virus and Murray Valley encephalitis virus typically cause quite varying degrees of neurological disease, and Ross River joint soreness and arthritis. So we had about 1,000 equine cases, all within the period of about 3 to 4 months during this sort of rain pattern period. And some of them were bad enough that they had to be humanely euthanized. Okay. So we lost about 10% of about 1,000. When we did the genetics on this new Kruger virus, we actually showed that it had mutated and evolved to look like West Nile virus. Okay? Had acquired 2 mutations in the areas that were responsible for neuroinvasiveness, meaning that it could invade into neurons and cause disease. So this virus is now in circulation, but probably thankfully, a lot of the horses got exposed to Kruger and didn't develop any disease, have some sort of partial protection. We just nasty. The next 10 years to get another sort of outbreak, I guess. Insect threats, changing distribution of things like Lyme disease and pigeon fever in the US and Canada is really quite stark. Lyme disease is, I'm sure you're all familiar with it, it's something that's transmitted by ticks, has reservoir hosts of small wild rodents, and survival and breeding of specific ticks and the Ixodes ticks are really quite important. And this is sort of a distribution of tick abundance, and you can see basically as we get browner, the abundance increases. I've got the actual numbers there, but as you can see here, with this sort of part of the world, you're going to see more and more ticks being more and more prevalent over the next 10 to 20 years. And with that will bring Lyme disease and other tick-borne and insect-borne disease. So there was an outbreak of Potomac horse fever, I believe in 2008, 2009 around these parts. That's related again to ticks and insects, not so much the biting of those ticks and insects, but actually the ingestion of dead insects incidentally, either through water or pasture. And it's those insects that harbour the bacteria that causes things like Potomac horse fever that were being trafficked in. During that 2008-9 period, I think Nick was telling me that was a particularly humid and warm period in this part of the world. Again, sort of related to climate change and insect threats. Pigeon fever. I'm amazed at this disease. We don't see it in Australia, I don't know why, but it seems to be a phenomenon specific to the US. Transmitted from the soil through biting insects to the muscles of the horse and causing these abscesses, muscle abscesses. And again, increasing mosquito populations, more mud, more water around the environment to facilitate the transmission of this particular pathogen with greater frequency. Now, this organism is now widespread. This disease is everywhere in progress. People are telling me, I have colleagues in Central Oregon that are saying that we're seeing this every year now. We never used to see this 20 years ago. It's now a summer occurrence that happens in a lot of places. Okay? It's probably likely it's happening here in the Pacific Northwest. Bugs that love the heat, okay, increasing in temperature and humidity, bacterial and fungal growth is going to be on the increase. So, like I said before, a lot of these bugs that are in the soil or in the environment are pretty harmless, but if they get to really high doses, they can be quite nasty. Okay. The things we need to worry about in our horse environment is things like water troughs, things like feed troughs, that if they're in high temperature environments, humid environments, those equipments can easily be contaminated with environmental organisms. Those organisms can cause little biofilms on those equipments, and effectively every time the animal goes for a drink, it's going to get a big gulp of whatever that biofilm is, which is going to be these nasty bacteria and potentially cause disease. Not only the ingestion of the water, but potentially aerosols from the water may result in respiratory disease associated with these bugs. So be aware of that, and be aware of other things that are going to potentially compromise the animals, like wildfires and the inhalation of poor quality air that may compromise the respiratory tract of those animals. So there's a variety of these opportunistic bacterial and fungal diseases, Pseudomonas diseases, Klebsiella, fungal diseases like mouldy feet, aspergillosis. They're going to become more and more of an issue. We need to sort of try and manage our environments accordingly. I think symptoms like greasy heel and rain scald, I think they're going to become more and more of a problem with our horses that are kept in relation to the humid conditions, the insects that are going to enable penetration of skin easily from one animal to the other. That particular organism just loves in moisture heat combo. Just allows it to be transmitted easily, the compromisation of the skin in relation to moisture and heat. And then obviously some of the management strategies we have, like brushing horses and potentially trafficking the bacteria through brushes and rakes that are used between horses. All those sort of things are going to contribute to increasing prevalence of this particular disease. Grazing and rain scald, being aware of that. So, how do we try and act in a way to try and reduce the risk of these diseases? So, there's probably 5 or 6 sort of points that we need to worry about. We need to understand the equine ecosystem and how those interactions actually work. And it's only through actually understanding that can you actually intervene to stop it from occurring. Okay? So understanding that, having the awareness of some of the negative impacts of climate change and specific climate change events that are predicted and are going to impact upon equine health. Be savvy as individuals, the power of one type of principle, because there are lots of people out there that are giving us lots of information about climate events. So surveillance and monitoring. Your state climatology officers are producing great things in terms of material that are showing trends and forecasting. Use them. Don't be afraid to get involved and ask questions from these people. Hopefully your Department of Ags have systems in place where they are monitoring diseases using sentinel animals such as these chickens, or chooks as we call them in Australia. A lot of them will carry can become infected with a virus and produce an antibody response to it, but not actually develop disease. And these chooks are spread all over Australia, and so give us an indicator if insect-borne viruses are coming into certain zones. And that information should be relatively available to you guys, and if it's not, you demand it, because then you can act upon it. Okay? Because then you'll know. And then obviously the horse environment itself. So be proactive in terms of taking measurements yourself. Maybe doing some environmental bacteriological surveillance yourself. Getting a few swabs and swabbing a few feed troughs. Have a look at your water tanks. Okay, see if you've got an issue. Break breaking the connection, okay, trying to prevent transmission. And with insect-borne diseases, well, it can be, you know, relatively using insecticides and repellents to try and reduce that. With wildlife, it's all about trying to wildlife proofing your housing that you're using, you've got your horses in. Sometimes that can be difficult, sometimes that can be easy, especially with flying animals like birds and bats. You can potentially do simple things to stop those animals getting into your stables, for example. And basic hygiene. You've got to remember that bacteria there, if you're having clean environments, not so much organic material around for bacteria to utilise, it'll be a better environment and it'll be a healthier environment for the horse. Environmental measures. Elaine's done some fantastic things in relation to mud management. I think it's great. I think in relation to climate change, probably the most important thing you can ever do is reduce the likelihood of mud being an issue on your property, because that's going to reduce the likelihood of insects going to be a problem on your property, and the likelihood of you having animals contracting pigeon fever and all that sort of stuff. Right? Providing adequate shade and shelter, having an understanding of the topography of your where you're keeping your animals. Where are the trees? What are the sort of soil types that are there? Are these factors contributing to increasing risk of wildlife encroachment or increasing risk of water pooling? Is it associated with runoffs and drains and things like that? And basically trying to understand those environmental measures to try and avoid animals going into high-risk climatic environments. And then the host or horse management. And that revolves around what you're exposing your animals to directly. Nutrition, making sure that's up to scratch. Making sure your housing and equipment that you're using is good and not trafficking viruses or bacteria. Vaccination for some of these viruses are, like I said, be aware of it because the viruses are changing and the vaccines may not be totally. You get to use vaccines in your management strategies of horses. It's not a golden bullet. It's not a silver bullet, sorry. Okay? It works best in combination with good husbandry measures, okay? And understanding of what's going on in the horse's climate. Reducing stress and trying to conserve natural habitats on your outskirts. If you can conserve that, it's going to be less likely wildlife's going to come in and look for food in your habitat. Okay? And ultimately what we're trying to do is aim to favour the horse as much as possible. Okay? And try and do that with smart management, utilising material that's out there in terms of resources, and just being very much aware of the holistic nature of the horse's environment. Right, any questions?
You talk about animals affecting. I have a problem controlling the mice and the rat feces in my hay, in my barn. How does that affect the horse? I mean, I try not to feed that hay if it's had contact with it, but it's been really difficult.
Yeah, and that's, rats can harbour a hell of a lot of different pathogens into your system. Leptospirosis comes to mind straight away with horses, and a variety of different pests. So, yes, you're doing the right thing by avoiding it. How do you manage that? Well, keeping pet snakes. That's what I do in Australia. That keeps the rat population down. But yeah, it can be really difficult. And a lot of the time it just revolves around trying to, again, that sort of animal proofing where you're keeping your hay and your food sources. It's very difficult, I know it is. But these are just ideas that are up there, and if we can sort of think as a group to try and produce some strategies that can be used in various settings, then that would be great.
I have two questions. The first one is the issues that come up on the large showgrounds, large show facilities, where those of us who have had issues with it believe that there is fungus and other microbial things happening in the footing, and all it takes is for the horses to get scratched or whatever while they're there, and suddenly there's this very strong strain of bad stuff that you can't get rid of. And is there anything that can be done to treat, not the horses, the bacteria in the footing?
So you're talking about the bacteria on the feet or in the soil environment?
In especially sand environment.
Yeah. Again, extremely difficult to do. And like I said, conscious of the potential risk in those environments, that where you've got humidity, temperature, all those countering positively for the pathogen, the only thing you can really do to protect your horse is to maintain the foot care of the horse if it's a foot problem. So making sure it goes into that environment without any cracks or crevices, maintaining good foot hygiene, good foot care in terms of shoeing, etc. Very little that you can do environmentally about it, except for going to the extreme of excavating and putting new soil in. Difficult to manage. Okay? That's why with these sort of things, in certain areas it's possible, like the feeding troughs and the water troughs and those sort of things, where you've got a specific source. But if it's just all out there in general, it's about bringing your animals into that environment with a degree of protection. And that's maintaining good horse health. Contracting those pathogens. But you're right in relation to, big events. It's the time where transmission of disease occurs most prevalently, because you've got large numbers of horses, ground's getting torn up all the time, and the likelihood of contracting disease is going to increase. Is there something else?
Yeah, I had just a second question. That is that last summer we were part of a study that looked at potential health benefits of bedding horses on composted stable waste, essentially. So it's the bedding reuse, and the for the very short answer on this, the probiotic effect really of having this material. And I'm just curious whether you're aware of any other studies that have been done.
I only have a concern about that with certain bacteria, and especially with foals and young animals. There might be that positive effect of probiotics, but my concern would be that composting is not going to remove nutrition that bacteria can use. Okay? So the compost may kill all the bugs in the feces, but it's not going to contribute to what's on the soil at the time that you're putting the compost on. And if that's contaminated and you're bringing in nutrients into that environment, then that could be a potential problem. So I'm not pro or against it, but I just like to make people aware of the negatives that could occur, and specifically animals, specifically young foals that have an issue with rhodococcus, that might have an issue with rhodococcus equi, or you may develop an issue with rhodococcus equi because of those strategies. Okay, the classic example I have of that is the use of composting in Ireland. And they were using composted fecal material on lunging rings in racing stables. And they were seeing these 2-year-olds coming there with upper respiratory disease, which they diagnosed as rhodococcus equi. Okay? It's because they were being trained on shit, and the shit was facilitating proliferation of the organism that they were inhaling. Okay? So it's this balance that you've got to be aware of, the interactions that you've got to be aware of, and the pros and negatives, and then making a decision accordingly. Yep.
So given what you've seen, given everything you just said, how serious do you think it's going to get?
How serious? Gee, it's a $20 million question. I think it'll be as serious as you guys let at the end of the day. I think there's a lot that we can do as individuals to protect the environment that our horses are in, and collectively as communities, I think there's a lot that we can do too. And that is the utilisation of climatologists, the utilisation of our Department of Ags to better inform livestock managers, including horse managers, of the risks. And then all it's then up to you guys to actually do something about it. And sometimes there are things that you may not be able to do anything about it, and then you'll have some issues. But a lot of these things are maybe not preventable, but reducing the severity is what we're trying to do. Any other questions? Thanks.
Okay, so thank you very much, Dr. Gary Muscatello, my formal, formal. Really appreciate hearing from you today. Gary will be here for the whole day, so if you have questions, you'll be able to during lunch, and also Chad Kruger is here for the rest of the day as well, and you'll have access to him. Nick Bond unfortunately had to leave early, and I apologize for not letting you know that in advance so that you could snag him over the break before he left for the day. But we do have his contact information for you if you decide you want to follow up with him on specific climate change related questions. So, take home messages, I guess, from Gary's presentation. Horses, not unlike humans and other organisms, basically are more susceptible to disease. The risk is higher when we're stressed out, when they're stressed out. So we want to do whatever we can to try and minimize the effects of stress so that the animals are healthy and able to respond with strong immune systems to counter diseases that they're getting exposed to. And we're not going to be able to cover all of the practices here today that you are probably asking yourselves questions about, things that you could be doing, how you might want to modify some of your practices in order to address some of the concerns that you have as a result of hearing Gary's presentation or the earlier presentations. We are going to focus later today on some of the core practices around pasture management and water management. And I think that what I heard also from Gary is that, the things that we do here in the Northwest around mud management and manure management are really important in that as well. And we'll have to save for another day diving into a lot of detail about manure management and mud management. Oh no, actually Elaine's going to touch on that a little bit today with water. No?
Well, water conservation, not really.
Not really, yeah. So that's just the limitation of what we can focus on here today, but let's not lose track of the fact that those are important practices that you guys are all doing now that we want to continue to do, and we all want to explore how we might be able to do them even better. Okay, so we're going to break for lunch. I left my schedule at my table. I think we're running about 10 minutes late, so I'm going to ask that instead of thank you. Instead of coming back from lunch at 12:15, instead of giving ourselves another 10 minutes, we still try to come back at 12:15. We're in here for lunch. There's tables, and food is set up on my left. And snag your food and grab who you want to talk to, and let's have some good conversation, and then come back by 12:15.
You can see the vendors too.
Yes, and the vendors will be stocking their booths as well.
I'm making a lunch break backup one. Okay, because this one's not. Should we try to see if that'll work? Then when you're
reduce their numbers and bring them down to a level that they could sustain. Now that was a terrible decision for me to make.
to the presentation. Conservation sort of movement, this phrase, future-proofing your land and your horse and your animals. So that's what we're looking at here, is how to future-proof your land and how to future-proof your animals to manage the uncertainty that climate change presents. And the session is going to be moderated by a different person. I'm not going to do it. I'm just going to introduce Elaine Blickley, who I know most of you know from Horses from Clean Water. She's going to moderate this afternoon session. And I'm going to turn the mic over to her and let her get going, okay?
I use this mic? I guess you should. Thanks, Elaine. Yes, thank you.
Yes, thank you. So what we're going to try to do is introduce some new thinking, and some ways to maybe think outside the box and present some new options of keeping in the face of climate change. So the two main topics that we're going to be addressing are pasture management and water conservation, because we figured those were probably two of the biggest ones that were going to be affected by climate change as far as horse keeping. So for first on pasture management, we have an awesome, inspiring video for you folks to watch. We're all going to watch it together. And then we have a speaker for you. We have Sandra Matheson, and she's from Bellingham, and she is an Allan Savory person who's, Allan Savory is the speaker for the TED Talk that we're going to be watching. And we're lucky enough to find an expert in our own backyard on this topic. So she's going to follow up with a short presentation about how we can perhaps take the Allan Savory method and translate it towards or to horses in the Pacific. And then we're going to have a panel discussion with several different experts that we'll introduce after that. And we're going to talk more about pasture management in the Pacific Northwest and how we can maybe look at some new ways to pasture management and see what we can do to improve our pastures here. And then I will be on deck talking about water-wise conservation after that. So for folks at home, there is a link on your screen, and you can just watch the video live that we're going to be showing, but there's also a link. And if you click on that link, you'll have, it'll take you right to the TED Talk, and it'll be a better viewing session for you of that TED Talk. So if you want to do that, you can do that. And then now we're going to watch a TED Talk on pasture management.
The most massive tsunami, perfect storm is bearing down upon us. This perfect storm is mounting a grim reality, increasingly grim reality, and we are facing that reality with the full belief that we can solve our problems with technology, and that's very understandable. Now, this perfect storm that we are facing is the result of our rising population, rising towards 10 billion people, land that is turning to desert, and of course climate change. Now there's no question about it at all. We will only solve the problem of replacing fossil fuels with technology. But fossil fuels, carbon, coal and gas, are by no means the only thing that is causing climate change. Desertification is a fancy word for land that is turning to desert, and this happens only when we create too much bare ground. There's no other cause. And I intend to focus on most of the world's land that is turning to desert. But I have for you a very simple message that offers more hope than you can imagine. We have environments where humidity is guaranteed throughout the year. On those, it is almost impossible to create vast areas of bare ground, no matter what you do. Nature covers it up so quickly. And we have environments where we have months of humidity followed by months of dryness, and that is where desertification is occurring. Fortunately, with space technology now, we can look at it from space, and when we do, you can see the proportions fairly well. Generally, what you see in green is not desertifying, and what you see in brown is. And these are by far the greatest areas of the Earth. About 2/3, I would guess, of the world is desertifying. I took this picture in the Tihama Desert while 25 millimeters, that's an inch of rain, was falling. Think of it in terms of drums of water, each 200 liters. Over 1,000 drums of water fell on every hectare of that land that day. The next day, the land looked like this. Where had that water gone? Some of it ran off as flooding, but most of the water that soaked into the soil simply evaporated out again, exactly as it does in your garden if you leave the soil uncovered. To soil organic matter, when we damage soils, you give off carbon. Carbon goes back to the atmosphere. Now you are told over and over, repeatedly, that desertification is only occurring in arid and semi-arid areas of the world. And that tall grasslands like this one, in high rainfall, are of no consequence. But if you do not look at grasslands, but look down into them, you find that most of the soil in that grassland that you've just seen is bare and covered with a crust of algae, leading to increased runoff and evaporation. That is the cancer of desertification that we do not recognize till its terminal form. Now, we know that desertification is caused by livestock, mostly cattle, sheep and goats, overgrazing the plants, okay, leaving the soil bare and giving off methane. Almost everybody to golf caddies, or was taught it, as I was. Now, the environments like you see here, dusty environments in Africa, where I grew up, and I loved wildlife, and so I grew up hating livestock because of the damage they were doing. And then my university education as an ecologist reinforced my beliefs. Well, I have news for you. We were once just as certain that the world was flat. We were wrong then, and we are wrong again. And I want to invite you now to come along on my journey of re-education and discovery. When I was a young man, a young biologist in Africa, I was involved in setting aside marvelous areas as future national parks. Now, no sooner, this was in the 1950s, and no sooner did we remove the hunting, drum-beating people to protect the animals, then the land began to deteriorate, as you see in this park that we formed. Now, no livestock were involved, but suspecting that we had too many elephants now did the research, and I recommended that we would have to reduce their numbers and bring them down to a level that the and it was political dynamite, frankly. So our government formed a team of experts to evaluate my research. They did, they agreed with me, and over the following years, we shot 40,000 elephants to try to stop the damage. And it got worse, not better. Loving elephants as I do, that was the saddest and greatest blunder of my life, and I will carry that to my grave. One good thing did come out of it. It made me absolutely determined to devote my life to finding solutions. To find national parks like this one desertifying as badly as anything in Africa. And there'd been no livestock on this land for over 70 years. And I found that American scientists had no explanation for this except that it is arid and natural. So I then began looking at all the research plots I could over the whole of the western United States where cattle had been removed to prove that it would stop desertification. But I found the opposite. As we see on this research station, where this grass by 2002 had changed to that situation. And the authors of the position which I obtained these pictures attribute this change to unknown processes. Clearly, we have never understood what is causing desertification, which has destroyed many civilizations and now threatens us globally. We have never understood it. Take 1 square meter of soil and make it bare, like this is down here, and I promise you, you will find it much colder and much hotter at midday than that same piece of ground if it's just covered with litter, plant litter. You have changed the microclimate. Now, by the time you are doing that and increasing greatly the percentage of bare ground on more than half the world's land, you are changing macroclimate. But we have just simply not understood why was it beginning to happen 10,000 years ago? Why has it accelerated lately? We had no understanding of that. What we had failed to understand was that these seasonal humidity environments of the world, the soil and the vegetation developed with very large numbers of grazing animals. And that these grazing animals developed with ferocious pack hunting predators. Now, the main defense against pack hunting predators is to get into herds, and the larger the herd, the safer the individuals. Now, large herds dung and urinate all over their own food, and they have to keep moving. And it was that movement that prevented the overgrazing of plants, while the periodic trampling ensured good cover of the soil, as we see where a herd has passed. This picture is a typical seasonal grass, and it's now going into 8 months of dry season. And watch the change as it goes into this long dry season. Now, all of that grass you see above ground has to decay biologically before the next growing season. And if it doesn't, the grassland and the soil begin to die. Now, if it does not decay biologically, it shifts to oxidation, which is a very slow process, and this smothers and kills grasses, leading to a shift to woody vegetation and bare soil releasing carbon. To prevent that, we have traditionally used fire. But fire also leaves the soil bare, releasing carbon. And worse than that, burning 1 hectare of grassland gives off more and more damaging pollutants than 6,000 cars. And we are burning in Africa every single year more than 1 billion hectares of grasslands, and almost nobody is justify the burning as scientists because it does remove the dead material and it allows the plants to grow. Now, looking at this grassland of ours that has gone dry, what could we do to keep that healthy? And bear in mind, I'm talking of most of the world's land now. Okay? We cannot reduce animal numbers to rest it more without causing desertification and climate change. We cannot burn it without causing desertification and climate change. What are we going to do? There is only one option. I repeat to you, only one option left to climatologists and scientists, and that is to do the unthinkable and to use livestock, bunched and moving, as a proxy for former herds and predators and mimic nature. There is no other alternative left to mankind. So let's do that. So on this bit of grassland, we'll do it, but just in the foreground. We'll impact it very heavily with cattle to mimic nature, and we've done so, and look at that. All of that grass is now covering the soil as dung, urine, and or mulch, as every one of the gardeners amongst you would understand, and that soil is ready to hold, absorb, and hold the rain, to store carbon, and to break down methane. And we did that without using fire to damage. When I first realized that we had no option as scientists but to use much vilified livestock to address climate change and desertification, okay, I was faced with a real dilemma. How were we to do it? We had 10,000 years of extremely knowledgeable pastoralists bunching and moving their animals, but they had created the great man-made deserts of the world. Then we had 100 years of modern range science, as we first discovered in Africa, and then you see in this picture of land managed by the federal government. Clearly more was needed than bunching and moving the animals, and humans over thousands of years had never been able to deal with nature's complexity. But we biologists and ecologists had never tackled anything as complex as this. So rather than reinvent the wheel, I began studying other professions to see if anybody had. And I found there were planning techniques that I could take and adapt to our biological need, and from those I developed what we call holistic management and planned grazing, a planning process. And that does address all of nature's complexity, social, environmental, economic complexity. Today, we have young women like this one teaching villagers in Africa how to put their animals together into larger herds, plan their grazing to mimic nature, and where we have them hold their animals over and so on, and they do this and hold them overnight to prepare the crop fields, we're getting very great increases in crop yield as well. Let's look at some results. This is land close to land that we manage in Zimbabwe. It has just come through 4 months of very good rains, got that year, and it's going into the long dry season. But as you can see, all of that rain, almost all of it, has evaporated from the soil surface. Their river is dry despite the rain just having ended, okay, and we have 150,000 people on almost permanent food aid. Now let's go to our land nearby on the same day with the same rainfall, and look at that. Our river is flowing and healthy and clean, it's fine. The production of grass, shrubs, trees, wildlife, everything is now more productive, and we have virtually no fear of dry years. And we did that by increasing the cattle and goats 400%, planning the grazing to mimic nature and integrate them with all the elephants, buffalo, giraffe, and other animals that we have. But before we began, our land looked like that. This site was bare and eroding for over 30 years, regardless of what rain we got. Okay? Watch the marked tree and see the change as we use livestock to mimic nature. This was another site where it had been bare and eroding, and at the base of the marked small tree, we had lost over 30 centimeters of soil. Okay? And again, watch the change just using livestock to mimic nature. And there are fallen trees in that now, because these are now, the better land is now attracting elephants, etc. This land in Mexico was in terrible condition, and I've had to mark the hill because I began helping a family in the Kruger desert in the 1970s, turn the desert that you see on the right there back to grassland, and thankfully now their grandchildren are on the land with hope for the future. And look at the amazing change in this one, where that gully has completely healed using nothing but livestock mimicking nature. And once more, we have the third generation of that family on that land with their flag still flying. The vast grasslands of Patagonia are turning to desert, as you see here. The man in the middle is an Argentinian researcher, and he has documented the steady decline of that land over the years as they kept reducing the sheep numbers. They put 25,000 sheep in one flock, really mimicking nature now, with planned grazing, okay, and they have documented a 50% increase in the production of the land in the first year. We now have in the violent Horn of Africa pastoralists planning their grazing to mimic nature and openly saying it is the only hope they have of saving their families and saving their culture. 95% of that land can only feed people from animals. I remind you that I am talking about most of the world's land here that controls our fate, including the most violent region of the world, where only animals can feed people from about 95% of the land. What we are doing globally is causing climate change as much as, I believe, fossil fuels, and maybe more than fossil fuels. But worse than that, it is causing hunger, poverty, violence, social breakdown, and war. And as I am talking to you, millions of men, women, and children are suffering. And if this continues, we are unlikely to be able to stop the climate changing even after we have eliminated the use of fossil fuels. I believe I've shown you how we can work with nature at very low cost to reverse all this. We are already doing so on about 15 million hectares on 5 continents. And people who understand far more about carbon than I do calculate that for illustrative purposes, if we do what I'm showing you here, we can take enough carbon out of the atmosphere and safely store it in the grassland soils for thousands of years. And if we just do that on about half the world's grasslands that I've shown you, we can take us back to pre-industrial levels while feeding people. I can think of almost nothing that offers more hope for our planet, for your children, and their children, and all of humanity. Thank you.
Okay, what did you think? It's a lot to take in.
I know I've watched it many times, and there's still a lot that's going through my mind when I'm watching that video. So you all, just to remind you, you're going to have the proceedings from this event available to you, whether you're at home or here. We're going to give you a site where you can go and download the presentations, as well as you can look up this TED Talk and re-watch it yourselves. So Matheson as a speaker to explain a little bit more about the Savory method of pasture management, particularly for us here. Let me introduce a little bit about Sandra. She is the president of the Pacific Northwest Center for Holistic Management in Bellingham. And this is a group of holistic management educators, farmers, ranchers, university, extension agents, and others who have formed a hub of the Allan Savory Institute. The mission of the Center for Holistic Management
be harmful. I actually had always learned before holistic management that that animals are causing the degradation that's going on in many parts of our world, in many parts of this country. My first visit to New Mexico I was amazed. It was a totally different country. There was so much bare ground. It was pretty sad looking compared to what I'm used to over here. But the thing is that I'd always been told is because there were too many livestock. And so that day that I arrived, we drove about 3.5 hours north through New Mexico, and I figured it was a big aha moment that those dozen head of cattle were not causing all that damage in New Mexico, and that there was something else going on. Back in terms of talking about controversy, Chad had mentioned that one of the concerns was that there's not a lot of scientific research to document this, and that is something that the Savory Institute and many others are working on to actually have that scientific data available. We'll talk a little bit later about why. But for those of us who have been practicing holistic management and using planned grazing, I mean, we have seen tremendous, amazing changes on animals. And, for those of us that are doing it, it's a no-brainer. We see it in action. And so, but we do understand we do need to have the research. Listening to what Allan has to say is going to cause some paradigm discomfort, I guess is what I'm trying to say, for many people. And it's actually actually based on, pretty old nature, but it is going to require some paradigm shifts. What we're talking about is that that a lot of times we see the problems that we have even with climate change. We're looking at all the storms that we're having, the violent weather, all these things, droughts, all of those, and we're putting billions and billions of dollars into trying to fix those things or repair those things that have happened, whereas really we're spending money kind of on the Band-Aid effect, and there seems to be a reluctance to put the money, the time, the energy into trying to get to understanding the root causes of the problems and trying to address those. I read the rising sea levels and the storm surges, and so there, to make sea changes that are occurring. And can you imagine what could all of us here do with $20 billion? And that's only one city. So there is, I think it's just time for all of us to kind of to wake up and put the politics aside and really look at how we're putting our resources in to try to really get to solving these problems and not just, putting a Band-Aid on it and watching it get worse. So I'm going to talk about, we don't have a lot of time, but I'm going to talk very briefly about how can what Allan Savory talked about, how can that even work? What is the process? I'm just going to talk about some of the highlights. Can we make a difference here with our small farms and small ranches, and particularly even in Western Washington, since we are a little different environment than what Mr. Savory was talking about. So I wrote, there should be no debate, although some people will still debate that there is a climate change occurring or problem occurring. But the Earth is warming. We all know that. We heard about that this morning, and we have a buildup of greenhouse gases, mostly carbon dioxide. And if we stay at this, the current rate at which we are increasing that carbon dioxide, we're going to lead to a situation that's going to be a pretty miserable place to live and a pretty tough situation all around. So currently we have reached that dreaded 400 parts per million, rising 2.1 parts per million per year. And even though climate change and the greenhouse effect, all those things have been talked about for the last almost 100 years or so, no one back then ever imagined that it would be changing this quickly. So we need to reduce those CO2 levels and reduce that concentration at least down to about 350 parts per million to try to keep things stable at the very least. So there are a couple of options, and the main option that you hear about all the time is that we need to stop carbon emissions or reduce carbon emissions. And that's the world today on that approach, and we'll talk about that in just a moment. And the second option, which we saw a little bit here just a few moments ago, is it possible that we can sequester a large amount of that carbon and reduce those CO2 levels? So is that a possibility? So fossil fuel emissions, according to this study, that if we need to, by 2015, reduce the emissions by 40%, by 70% by 2020, 90% by 2030. And I don't know about you, but I think we only have about 8 months left to reach that, and I don't think we're getting there. So maybe let's look at the second option. So how can we sequester more carbon? And some would say that's impossible. That's impossible to be able to take that much carbon out of the atmosphere and put it into the ground. But maybe it's not. Let's take a look. So there are approximately 4,700 tons of soil organic matter per hectare of soil to a depth of 33 centimeters. So if you could increase the soil organic matter by 1%, simply 1%, you could then have add 27 tons of carbon to the soil per hectare. Okay, and that's quite a bit. that could be an option. And if we were to spread that over 5 billion hectares of the world's grasslands, that equals about 135 gigatons of carbon, and gets us down to a level which we are of 66 centimeters, doubling that, we have more than enough to get back to those levels, which are going to put us in a lot better situation to be not so long ago. So is this even possible? So, well, I look at it like this, is that we have lost historically about 500 gigatons of soil carbon over the last years. And so if we have lost that much, that means the soil has at least that much capacity, right? So if there is a way to put that back into the soil, then we could essentially then solve the problem. So what's the an ideal solution look like to this climate change problem? It would be a low-tech solution. I mean, technology has been good for us. It's certainly solved a lot of problems, made our lives easier. But however, it's also created many problems as well. So let's look at a low-tech solution. Let's look at something low cost. I mean, we're spending all that money having to build those seawalls and such. Maybe there's something that's a little less expensive that we could do to actually get a little closer to the root cause of the problem. And what if that solution actually helped farmers and ranchers be more sustainable? I mean, and I'm talking not only in terms of the environment and farming more sustainably, but actually being able to deal with the social human aspects of it as well, so that they can have a better life, and also they can make a profit so they can stay in farming and continue to do what they love to do and to be able to feed. Is if that solution also could help us feed 9 million people, that would be a pretty good solution. And so that's what we saw in the TED Talk. This actually are this cattle in eastern Washington that are grazing on former wheatlands. And you see some of the wheat fields in the background. And in 1 year, just covered that soil, virtually eliminated the erosion that was going on in there. And someone was able to grow those cattle and to actually make a profit on that, both the landowner and the rancher who also no debate that livestock have been vilified for some reasons. And some of those reasons are that they definitely can cause degradation and that animals have overgrazed plants. But I also want to point out that the effect that these animals cause is based on management. It's based on human decision making. It's based on the way that we, where we put those animals and when we put. And any tool, really, any tool can be used improperly, and livestock have basically just improperly. But livestock can also be regenerative. And this is my farm in Bellingham. And this is actually a ranch. This is at the Cinch Buckle Ranch in Montana. They have, I think currently they have about 60 horses, but the people who manage the ranch have also managed places used planned grazing and used it very successfully. And this, actually, I'm sorry I didn't talk about the picture and the pretty much bare. So this is the neighbor who is using planned grazing right next door. So it used, it's not just the animals themselves. I think we have something to do with it, we as humans. So holistic planned grazing is what Allan is talking about. And holistic planned grazing is helping us to manage the complexity. Nature is extremely complex, just like human societies and even difficult to consider into managing those animals and to manage that land that we're trying to improve. So we need a process to do that. And again, we're mimicking nature. And the way that we do that, since we probably prefer not to have, and we do have fences, so we can take advantage of the technology of, fencing and actually move those animals, keep them bunched, move them more quickly, and plan those moves so that it's not just random or it's not something on the calendar, and to allow those plants a chance to recover. Just like when the herds went through, they defecated, they urinated, they were being pursued by predators, they moved on, they didn't come back for quite a while, depending upon what type of environment it was, until that land, until those plants had a chance to recover. And so plant recovery time is the real key for holistic. And when you don't allow those plants a chance to recover, if you leave the animals too long or you come back too soon before the plants have had a chance to regrow, that's when you get overgrazing. And again, animal impact can have some many beneficial effects, just like any other sort of tool. If you abuse it, and in our muddy area, we have to be very careful. You put a lot of animals in a wet area for a long period of time, you've got nothing but mud. So again, but animal impact can be used and is being used to create positive results. So what is holistic management is not. It's not continuous grazing. By continuous grazing, I mean leaving the animals in a piece of land for a long period of time, which is probably what most small farms here in Western Washington do. Is you put the animals on, a few animals on 20 acres, leave them there for a month or two, and maybe you've got a second pasture, maybe you move them, or maybe you don't, and this is what you end up with. It's not rotational grazing. It's often mistaken for rotational grazing. There are similarities in terms that we have paddocks and we're moving them from paddock to paddock, but planned grazing is a very strategic planning and calculating of recovery periods and calculating and considering all those management factors that are really important to your particular operation and to the environment that you're just following the pattern. Based on a calendar. Many people will do the same rotation year after year the same way, and it is not even recommended to do that. So it is not based on calendar. It is more, or I should say, it's not a recipe. It's not the same thing every time. And it is not just randomly moving them here or there depending upon how you feel that day. So what it is an adaptive, dynamic system, or I should say process of management, managing the complexity of your pastures, your animals, the environment, your activity. So it is adaptive management, which is why it's been so difficult to have any sort of research. Most research is, as we heard earlier, you're trying to control a lot of variables, you're trying to keep things constant, and it doesn't work that way in nature. There's a lot of stuff going on, and a lot of things are happening, and it's adaptive management. So, and again, you're monitoring, and you have to change it from time to time, and so that's what makes it a little bit more of a challenge. But we are working on ways to create some what we see in practice. It is based on what we call a holistic context, or it's kind of it's like your vision, it's what you want most in life, how you want your life to be, and all of your decisions in holistic management are based on that. And your grazing plan is going to be, based on what's important to you and your family or your business. And it's also taking into they're not the same as cows, they're not tall cows. different, and they have, some of them have each species has their own unique characteristics and habits and nutritional requirements and things like that. And so you are considering those unique characteristics of the animals. And all of the management considerations, the things you might be concerned about, whether an area is too wet, or maybe there's some nesting of some birds going on in a particular area, or you have to be out of town for a month, whatever it might be, all of these considerations are carefully planned in. If you have a field that's going to be wet in the springtime, you want to avoid having the animals in, then you need to put that into the plan. So it does require careful planning. And this is really key here, because one thing I want you to remember is that the time that the animals are left in or before they come back to a pasture or paddock is more important than the numbers. Most people feel that it's too many animals that cause overgrazing. It really doesn't matter how many animals you have, as long as they're moved off before they're creating some problems with overgrazing plants or over impacting the ground. And just a very quick example is I had a beautiful pasture that I probably ran about 30 cow-calf pairs through several, I'd say 5 times during the grazing season. And they would spend about 2 days in there, the whole 30 pairs. One time I had a young bull I needed to find a place for, so I took that paddock out of my plan, not momentarily, but for a month, and left the young bull in there. And by the end of that month, there were many areas of that pasture that were overgrazed, the weeds had come up, the thistles were up, and I had to start feeding hay. And so there's one little bull calf, basically pasture. I ended up feeding him, and I got very little actual, feed in that month period of time as I would have if I would have had those 30 pairs going through. So it's, again, time is more important than the numbers. This is Eastern Washington, and even though it probably looks more like our area, this is near Spokane in an area that's using planned grazing. And it can happen all over the world. This, I believe, is in Mexico, or heard in Mexico. So the mechanics, just again, very briefly, because we only have a few more minutes, is that it is a plan done on paper. It's not in your head, it's done on paper. But the critical part is to put it on the paper. Fencing is also a part of it, to mimic nature, mimic the predator-prey relationship, and then we're constantly monitoring to make sure we're not taking too much, or if they're not taking enough, or if we need to wait before we move on. So the question is, can our small farms in Washington make a difference here? And we are in a very different environment than what Allan was talking about. We're more on the side with the green over there, that's near my house, where you stand still very long and you grow moss, and that but it does will be seen more in this brittle area. You still can make a tremendous difference here in this area. And just to finish up, one of my favorite books that I shared with my children was called If Everybody Did. It was by Joanne Stover. And what the book was it would, on one page, it would say, what would happen if everybody did, this, whatever it happened to be. And one picture might be pick a bud. And so it would show a garden of flowers, and then the next page is just a bunch of stems, and no flowers. And so that's what the book was about. It was about consequences. And so then, but the one that really got to me was, what if everybody made a smudge? And it was black, completely black page, and it's so true. I mean, individually, what we do by ourselves might not seem to make a difference, but collectively, we as a group of people, and we do represent a lot of acres here in this area, if we can make some small changes on our properties and we can sequester some carbon, we can, in the long run, make a huge difference and help us towards climate change. towards combating climate change. And I just wanted to add that from comments earlier that we're seeing a lot of emerging diseases because of dust and such, but what better way to prevent that dust is to grow grass. And so if we can do that, I think that will get us healthier as well.
And so we're going to have Sandra, if you want, you can stay up here and just grab a spot. And then Chad Kruger from earlier. And Gary is going to join us. And then we have two new additions to our people who are speaking today. And we have Renee Skaggs and Jay Miro. And Renee and Jay, I'm going to let you guys introduce yourselves. And we for you all. And I'll start with Renee and then Jay, and then I'll give you guys the questions once we're all ready here. Let's see, we're missing. That's it? Okay, just Gary. Okay, we're good. Okay, Renee.
So my name's Renee Skaggs. I'm a farm planner at the Pierce Conservation District, and I have been there over 15 years, and I'm also a small farm owner. I have 10 acres in Eatonville, and I have 7 horses, and I manage my pastures very intensively. I have 5 major main pastures, which I subdivide throughout the growing season into about 7 acres of pasture with the 7 horses. So they're out at night and they're in their paddocks during the day. They're locked in right now. They're out for a week, but they're back in because it's too wet out there right now. And they're very irritated about it. But I just came back from a grazing conference, and they were speaking in a way that I hadn't thought about before, that I move my horses roughly every 24 hours, but they're only out 12 hours. We get about 5 rotations throughout the growing season out of those 23 units. So really, my horses are only out on each unit 3 days, 2.5 days a year. So when they're out there, I probably only have about 10% wasted back and mow. I try to do it smaller than that to get it to look like it's been mown down. Most of it does, about 10% doesn't. But I found if I get it just a little bit smaller, I get into injuries. The horse is too tight for them, but I'm pretty darn happy that I don't have to feed May, sometimes half of April. And I probably would make it the whole rest of the summer without it, but my husband and I play polo, so we really have to put the fuel to these guys. So in July we start feeding supplements, but pretty happy to practice what I preach at home, and I feel that makes me a better farm planner. I can go to farms and say, hey, this is what I'm doing. This is how I do it. I go out and do this every day, so I feel for you. It's a little bit more work, but it's definitely a lot less hay, and my nutrients are used on the farm, and I have to bring in more nutrients to grow even more grass than I do. Thanks.
So I knew that Renee was a good example of this with her horses, and I think probably a better example pack my horses together like that. They sometimes can't get along with themselves, much less each other. So another sideline is that Renee and I are talking to Renee to convince her to do a class with me later on, so maybe we can go to her place and see these things in practice, so stay tuned. So our next livestock and farm planner person is Jay.
Hi, Jay here. Farm planner. This is almost the end of my 13th year, so I've been there quite a while. I'm also a pretty recent farm owner who just purchased 34 acres in Maple Valley. So we are now let's say I bring home to work or work to home, depending on what's going on. I don't have any horses, but I have sheep and goats and pigs and cows to be soon. Horses maybe, like many of you, struggling with, okay, I have about an hour and a half after work before the kids come home, and try and manage working in the rain and remodeling houses and all the other things you have to do to live and survive. So on top of, okay, how many feet of fence can I put up today, or when, where, and how I can rotate. So and like many of you, challenges where I have wet pastures and dry pastures and things going crazy right now. Damn, I wish it didn't rain. Yeah, okay. We'll send you home with a little rain, a little moisture in your truck. So.
Very good. Thanks, Jay. All right, so everybody already knows Sandra at the end, Chad, and Gary from our previous talks. So I'm going to start with 2 questions, and I'm going to go from the right to the left. You can choose to answer them how they wish, and then we'll take questions from you folks too, so you might be your pasture management questions. Is combat climate change through good pasture management, which I think you might have something to comment on. Okay.
Yeah, so how it applies to you guys, I have no idea. I'm not from here. But I mean, I can imagine that the ability to utilise livestock, whether it be horses, sheep, cattle, or what have you, to manage your grazing pastures suitably, and moving horses and moving livestock continuously, or not so continuously, depending on what's going on seasonally, and adjusting your plans is going to make for a much more sustainable landscape, which ultimately is going to, in many of the problems that we face, probably being mitigated to some degree. So I'm in support of that sort of theory. And in relation to pasture management, well, like Sandra said, a lot of the dust-borne diseases that we're going to face with drought conditions, if we can do anything to maintain pastures and maintain them on the ground so that we're not going to drought. Respiratory health, particles from dust. So, whatever we can do to better maintain animals on pasture rather than housing them on dirt and what have you.
I'm somewhat infamous now. Made some criticisms of Allan. It didn't really mean for it to come out as criticism, other than from the perspective of we do need more evidence, more durable, reliable evidence that these things work to answer the questions that he's asked. It is confounding from a scientific perspective to think about an experiment that would be able to document, the benefits of a differential grazing management system. And the publications that are out there, basically, it's really hard to see the benefits of any one manipulation over another, and the logistics of managing an experiment at the scale that it would take to look at to really authentically look at a savory system type of approach are monumental. It'd be millions of dollars, and I'd hate to be the grad student. But I think there's, from a scientific perspective, there's some changes happening. First of all, like I mentioned earlier, we've got this modeling project where the concept of a model is you can start to test ideas and simulate ideas that you literally couldn't ever put out in an experimental setting, and then be able to, point to where do we need to actually have better empirical understanding of the processes that are going on to measure them better. And then the other thing, and something we haven't quite had pulled together yet, is the changes in instrumentation and the ability to evaluate ecosystem scale processes and outcomes at an ecosystem scale through remote sensing and other instrumentation has dramatically changed just in the last 10 years. And so the ability and data collection analysis on top of a commercial situation where you might have 25,000 sheep grazing, be able to superimpose and actually build a data set that understands what the impact of that was is actually possible now, and 10 years ago it really wasn't possible. So I think the answer to the question is we don't really know in any kind of scientific sense. We have a lot of observational experience, and I think Sandy can talk about that much more than I could. But to really know and say, this is the right way for us to go as a society to solve the carbon problem. And I have some questions. Realistic is that math? And those are because 10, 20 years ago there were estimates of the amount of carbon that could be sequestered by cropping systems, and there was a really strong data set to support a lot of that analysis. And where we've kind of come to is, yes, there can be meaningful accumulations of carbon in soils with better management, but the early projections were on an order of 5 to 10 times more than what we realistically think we can do now. And so, that's some of my skepticism is more of a healthy skepticism that really start to drill down geographically, system specific, and what your options really are, the economics of the whole thing. The actual amount of carbon that's likely to be storable tends to be much smaller than the potential that's storable. You're right, and Sandy had these numbers that
I'm going to take the approach of looking at this a little more simply and maybe asking you guys how many folks did it recycled in the 70s or the 80s and recycled today? Or how many folks maybe drive a car or have a car that gets better gas mileage than they did as their first car? Now we kind of bring it to the horse owner level. I mean, who manages their manure and he composts or hauls off that maybe when they first got horses or had horses when they were a kid didn't? And this is just the next evolution. Thinking about our pastures not as turnout, not as exercise area, but part of a global system where those pastures have a function beyond just turnout, exercise area for our animals. Not only do those pastures have the potential to provide food for our animals, limited depending on the acreages we manage, but they do also have the potential to store carbon in the roots, in the biomass, organic matter that pasture can absorb and the soil can hold. So as we think about how we can be better stewards of our property, increasing our skills, and it is a skill. Pasture management isn't necessarily something you do and you always do it right, but it's something we're constantly improving on. Oh, that didn't work. Well, maybe 7 pastures didn't work and 23, right? It was an evolution to get to that point. So for us as land managers, thinking about how can we always make our farms better? How can we be better stewards of our property? this is kind of the next step for us as horse owners to be able to do to make our neighborhood, our county, our state, our country, our globe a better place. And you know, I think it's pretty easy to do. And you said it wasn't rotational grazing, but it is. It's really rotational grazing plus, right? It is really thinking about. Yeah, definitely. It is thinking about your pastures, what's going on out there, how high they are, how wet the ground is, what the impact of our livestock have on those pastures, and really thinking it beyond our animals getting exercise. Okay, what is the impact of those hooves, those mouths, and then the manure we apply either via the end of the horse or on the compost. So it's just thinking about all as a good system, and it's definitely something that we can do here in the number one, less brittle environment, because we do have it easier in some respects, harder in other respects after this one.
And that getting back to having to buy less hay, and probably, I don't know, maybe 60 at least % of that hay is coming from over the mountains. So if you think of all the carbon miles that we're putting on that hay that we're buying to bring over to our, so not only are you leaving your soils bare by overgrazing your pastures, which can increase the soil surface temperature 20 degrees, it can be up to 20 degrees hotter than grass. If you leave grass stubble of 3 inches out there. So if you have grass stubble of 3 inches and you have bare soil, the bare soil is going to be 20 degrees warmer, which will radiate more heat, and on and on. So it's all the tangential things, the carbon miles of the hay you're bringing in, taking all that carbon possibly in through using all the manure on your own place.
Before I studied holistic management, I remember being advised by, I don't know, picking on government agencies, but it was just a local agency, that our pastures are old, they need to be reseeded. And so we spent, I think it was about $300 an acre, and reseeded most of the one farm, all but one corner of it, which was probably a good 50, 60 acres or so. And only to have it, when it grew back, to be less than what it was before we. That was a little. And I also had the experience of having Steve Franzen come out to our property. There was a grazing conference going on in the area, and he needed a place to come out. And I said, "Oh, sure, come out. Come out to our place." And again, this is before holistic management and planned grazing. And what Steve taught me is what Allan said on the TED Talk, is not to look across the pastures, but to look down. And when he said, get down on your hands and knees and really take a look, and I did that for the first time, and I was actually shocked at how much bare ground I had here in Western Washington. I mean, like I said before, you stand still for very long, you grow moss or something grows, blackberries grow on you. But I had a lot of bare ground, and so then through the learning about planned grazing, completely turned that around, and got more perennial grasses, more biodiversity in general, more plant life. The animals were healthier, the plants were healthier, more biological activity going on. So for me, even here in Western Washington, where our climate is forgiving, we made a huge improvement in our land, in our pastures, and also we're able to carry. I think over the years, and we probably just even maybe over 5 years or so, probably increase the number of cow-calf pairs that we put on that farm about 2.5. So I guess the point I'm trying to make is that even though, you know, we're not going to see the extreme changes, you know, huge variation in changes that you would see in a more brittle area, a more arid area, we can make a tremendous difference. We have a huge capacity to increase the amount of organic matter in our soil. And so, and again, if more of us can do those practices and improve our own little pieces of land collectively, I think we can make a difference in, you know, improve water quality and all those things that are also important to us.
Okay, great. Now it's your turn. Audience members, Nikki has a microphone. What pasture management questions do you have, or what questions might you have for the audience, or for the panelists?
This question is mostly for Sandy. When you talk about rotational grazing, planned grazing not being rotational, I would just really like to, like, on a really practical level, what the specific differences are, and what's the planned grazing, you know, exactly like an example of on your place, how many animals you had, and how big was the area that they were in, and all that.
Okay. Yeah, the difference, and I think you said it well, is it's kind of, it's more than rotational grazing. I mean, obviously we have in both situations that we have a lot of paddocks, and the reason we create a lot of paddocks is so that we can allow more time for those plants to recover before those animals come back to that same paddock that they just left. And so, but plan on paper, you are calculating out what is your that those animals should be in that paddock, and you're considering fast growth and slow growth. You're also considering, as I mentioned before, you know, if you're going to be out of town, or if you've got a pasture that's wet that you need to stay out at certain times of the year, or if you're going to be haying, then all of those things are factors in the plan first, and then you plan, you know, backwards and forwards from those periods of times that you know you can't have animals in particular pastures. So there is calculation, there is math, and I don't like math, I hate numbers, but, and so I was mortified, you know, the first time I had to actually do it, but it was pretty easy, and it really doesn't take that much time after you've done it, you know, once or twice, and so, but it does require planning on paper, and there's a lot of what we call our holistic concept. We want as well as the environmental. So in terms of differences, yeah, you are looking at actually planning that, and then going out, you know, you're looking at the pastures, and when you go out to move the cows, or before you move the cows, or the sheep, whatever it might be, that, you know, you're determining how much impact are they having. Is it too much? Is it not enough? Are they, you know, taking too much, or will they take too much if I leave them in, or do they need to stay longer? And then you can also plan for drought reserve as well. You know, even though we're in a pretty perennial rainfall type of area, we still have a lot of rain. I think it was a year or so ago, we went almost 3 months, I think, without rain, and things were pretty darn dry. You know, our little pastures aren't used to that sort of thing. So there is a involved, as opposed to moving them kind of in a pattern. And I think that's where some of the bad press with holistic management has, or planned grazing has come out, is that people are assuming, you know, that they're the same thing. But if you are actually planning, and you are following through, and you are monitoring, and you're, you know, taking steps to get back on track, then there really should be no reason, barring a major catastrophe, that, you know, you should be able to do what you set out to do.
another question from our audience. How many of you guys already feel you're doing a pretty good job of pasture management and rotational grazing and monitoring all these different things? Okay, good. So we might be preaching to the choir.
Renee and I just came back from the same grazing conference, and one of the big take-home things that I'm going to take away and continue to share with all of you as I visit or have visited your farms is the bottom 3 inches of the grass to the horses. That belongs to the plant. If we want that grass to function, that grass to provide us with feed for our animals, want it to provide carbon, sink, want to hold the soil and continue to regrow, we can't think us being able to utilize that. So that plant needs that bottom 3 inches in order to perform its magical trick where you cut it or you graze it and it regrows. And you do it again and again. So it needs that bottom 3 inches. So if there's anything I can leave you with is really thinking about how low you graze that pasture. It doesn't take 27 paddocks. It can be 1. It's just really being careful not to consistently graze below that 3-inch level in order to keep that grass, that one plant or the million plants that are out there healthy.
Isn't it also a matter of getting them off? Because that's what Renee's doing, is only keeping them on for 3 days at the most and then getting them off before the plant starts to regrow, right? Mm-hmm. So that would be the problem with having a big, because you need to keep them in for a long period. The animal would be going back and re-eating the grass after it started to regrow.
Yeah, and that's how having multiple paddocks allows you to gives you as a human ability. You could spend 3 days talking about pasture and still have more to talk about. But it's really thinking, okay, how can I allow this plant to do its life cycle? Advantage of, but leave the parts that it needs in order to do its job.
Sandra, I have a question for you. I don't know if you know specifically, but in the TED Talk when Allan Savory said using nothing but livestock, we repaired these areas. So if they were all eaten down to the ground and there was nothing there, did they reseed or how did the plant life come back?
That's a good question. And probably one of the main things that helped was to be able to actually, again, even though there's not a lot there, to be able to bunch those animals, to have them urinate, have them defecate, to have them put some litter on the ground, whatever little bit of litter you have to start with. In a lot of the areas that you see pictures of, whether it's national parks or even many areas in eastern Washington, there's a lot of, you see a lot of bare ground, and sometimes you'll see a lot of plant material, but a lot of it's oxidized material. And so it's not actively growing and cycling nutrients, it's just dead, broken down very easily for probably a few years. And so if you can get animals to go and not only just munch on that, but also to step on it, to break that down and to get it in contact with the soil, then you can create a better on the ground. You've got natural fertilizer on the ground, urine and manure as well. So that is one of the things. So what oftentimes has to happen, I guess there are 2 ways that you could approach it. The one way is realizing that the animals may not have a whole lot to eat. Most places there's going to be something for them to eat, okay? And so you may have so they're going to move from this area to this area and to this area, and they're going to impact it. They're definitely going to impact that area, and they're not going to necessarily get fast. They can at least not only what's there, but to then put that in contact with the ground and create some litter. And so initially, maybe maybe you are going to, well, they're probably not going to have as much to eat, or maybe your stocking rate is not going to be as high. You still bunch them, but in terms of the the whole piece of property, maybe you are going to have less cattle initially, but you still bunch them, you still move them, you still are working through your grazing plan. And each year, I know I saw a tremendous improvement the first year, and you saw with the 25,000 sheep, 50% increase in forage after 1 year of the planned grazing with the sheep. And so, yeah, there wasn't a whole lot to eat when they started, and just like there wasn't a whole lot. Growing there, and so I did winter feeding, which put litter, and also again they defecate. And the next year, it was unbelievable how much difference I saw, a year later, in the response to that. So there are different ways you could do it. You either start with a smaller number of animals, and or realize that maybe their condition isn't going to be as good initially, but each year you are going to see improvement in terms of production of the forage. Or you could feed on some, if you have some really devoid areas, where there's like almost nothing there, then you could feed hay, winter feeding, for instance, or supplemental feeding on some of those areas to kind of, it's kind of like, mulching your garden, is to prepare that soil so that, the seed that is in the ground can then have a better environment to grow. Which is kind of interesting too, because it's one of the things that we have found is that, you see an area where there's not much growing there, and you think, well, nothing's going to grow, right? There's no seed, there's nothing, there's no plants there. But there's seed in the ground, and the seed can live for many, many years. And I saw quite a shift in the plant communities on my place. Things that I remember when I was a little girl I had seen, and then hadn't seen for probably 20, 30 years, and then all of a sudden now I'm getting this shift back to some of those more native plants, and then some other varieties that I hadn't seen very much of just by changing the conditions. Does that answer your question?
Yeah, so you're saying that the seed is there, and that's probably there in those environments that Allan was highlighting. Could you comment about the crust, the soil crust? Because he mentioned about that, and I always thought that soil crust was, you didn't want to damage that, but it sounded like he thinks that you get erosion because of that hard soil crust. So can you mention about that?
Yeah, that's a topic of controversy. I know that there are some researchers who have battles going on with Allan about that. My understanding, because I tried to read some of the research and try to draw my own conclusion from it, is that some of the studies in terms of the crust, I know that some conclusions were drawn that the crust actually allows more penetration of water and protects from wind erosion. And a little bit in terms of wind erosion by having a thick crust. But the problem with the crust in reality is that when we do get a lot of heavy rainfall in a very arid area that has a crust on it, most of that rain is running off. Now the studies said, well, no, it's the crust is more permeable than say an area that's had the crust disturbed. But my understanding on that particular study that's frequently been cited is that they pre-soaked the crust for 24 hours before they poured the water on to determine the permeability. Well, I mean, that to me, that's not a natural system at all. So, I mean, there is controversy, and yes, there probably are some benefits of the crust, and if you live in a super, super windy area, it may be helpful, but the disadvantage is that also pretty much nothing grows, not a lot grows in that crust, and that if you do not have soils that are covered with vegetation, that you are going to get, in my opinion, erosion. Anyway, that's my opinion. I know there's a lot of controversy. I don't know if anyone else wants to add anything about that. But and that's been the difficulty is there is a lot. And some of the things, because I've tried to really, I want to understand, why is there opposition to this. I think that in some cases it's just the research, in my opinion, my own meager opinion, is not really was done in a natural situation, and that we are seeing flash floods, and we are seeing wind erosion in these areas that do not have the vegetation growing. And if you disturb the soil, then you can't allow those plants to seedlings to grow and emerge and then grow some grass.
So we're just about out of time, but what I would say, Sandra, and maybe you can correct me if I'm wrong, but when 20 years ago or whatever, when I first heard of the Savory method, my way of thinking about it and explaining it is that it's managing your land like the buffalo in the Midwest, pretty much, and that they were on an area, they grazed it pretty intensively, they trampled down the dead plants, they left manure, they left urine, and then they left, and they were gone for maybe a year or however long, and it was grew back. And then those big massive herds would eventually move back into those areas. So that's my way of thinking about it. Is that accurate, would you say?
Yeah, I think that's kind of the basis for Allan Savory's observations, is that, and the important thing to consider too is in each environment that recovery time that's needed for those plants to grow is going to be very different. Here, in May and June, you can come back to the same pasture in a month and it's this high. Whereas in eastern Washington, maybe you're only going to make, in some areas, you might make 2, 3, 4 passes in a season if all's going well, but more often than not, you're not coming next year. And if you do get yourself in, not get yourself, but if we're in a drought situation, it may be a couple of years before we can come back. So you really, again, that's part of the dynamic, and what kind of environment you're in.
All right, thank you. And Chad, did you have something to add to that?
Reinforce that the ecosystem that you're in dictates what you can and cannot do. A brittle eastern Washington annual grass system, one of the considerations you need to have is you need to not have cows grazing grasses that keep them from going to seed at least once every third year. You've got to have them go system to regenerate it. And so you really have to know the system that you're managing in, and then use your observations to understand what impacts you're having, and evolve and change based on that.
Are those native annual grasses?
Yes.
The question was native annual grasses. Okay, I think we're out of time, so we'll go ahead and take like a 5 back for our last presentation on water-wise conservation. Thank you, panelists.
about ready.
Let's check it.
Yeah.
We're gonna make this person stand.
Elaine,
Elaine, where are you gonna stand? Not coming up here all the time because you.
I might have to move around a little bit to check the time and stuff like that. Like, yeah, but I don't know like where I am. Really? Go for it. Does the presenter mode also have the notes on it?
Yeah. So is this
It
is that
does?
looks like? There's.
Well, then I'd have to walk forward to read the notes.
Yeah. You'll get to read the notes.
So I couldn't figure out how to do it. Presenter mode. I know. No, you're not. Yeah, that's okay. Out there in front of all of us. Oh, I'm leading us. Yeah. I realize see what I'm saying. If you have more that you want to say. Can we set a phone sitting up next to it? What was that? A phone with a camera? Yeah.
I need mine to watch what's going on.
Yeah.
Listening to it. So
Oh, yeah. See what's going on.
So you guys might have to help me a little bit on this one. When Brandy and Nikki and I and our advisory committee were putting this all together, we weighed the afternoon we wanted to have as future-proofing, like what Brandy said. It's a term that I picked up in Australia when I was there in 2012. And that organization there, Horses SA, it's called, they're the ones that sponsored the I went to where I met Gary. They have materials, they have tip sheets, they have handouts, and all sorts of material on managing horses and climate change, and their tip sheets are called Future-Proofing Your Horse. So we are borrowing from the Land Down Under with that term, and we came up with the two topics that we thought might be most pivotal most important for us as horse owners in the Pacific Northwest to start thinking about. And the first, of course, was pasture management, which we just worked through. And then the next one was water conservation. So that's my with here. So water-wise for horse properties. Feel free to ask questions as we go along too, and join in if you're so inspired. Okay, water. It's kind of interesting to think about talking about water conservation in the Pacific Northwest, because water is everywhere. It's abundant, it's prevalent, it's beautiful, it's a big part of our lives. But I think that all of us, no matter where we are in the country or I'd say maybe in the developed world and in North America, we tend to take water to take it for granted, right? So water. Every product in the world somehow requires water in its manufacturing process. Anything from computer chips, which require water, to soft drinks, to making soft drinks, to automobiles, the entire manufacturing world. How about recreation? It's not recreation unless, for the most part, unless we have water involved somehow. Our greatest amusement parks are, pools and beaches and fountains and boats, and all. Water is how we, one of the main ways that we think of recreating, at least in the developed world. And in the developed world, in the last 100 years at least, water has become abundant, safe, and cheap, right? I mean, we don't think twice about turning on the tap and getting a drink of water here. And water is, pretty easy for us to get. It makes our lives and our worlds here a very comfortable place to live. Of water scarcity, from climate change, from the populations, for a lot of reasons, water is becoming more and more scarce. It's a good time to start thinking about it. Water is finite. It's basically like we live in a closed system. It's the water cycle, it's called. And the amount of water that we have here is what we have. We don't get any more, we don't get any less. And we're all recycling water. It's the same water that the dinosaurs had. Basically, we're drinking the same water that the dinosaurs drank, which is what these guys are. So let's talk a little bit about the water cycle. It's pretty basic. I know, and I'm not an expert on this. I'm just an educator here. Concepts. So let's just talk about it and review it so we can start thinking about this, and then we'll be able to move forward from here in looking at new, innovative ways to conserve water. So we have water in water bodies, lakes, creeks, streams, the ocean, wetlands, and water evaporates from there and goes into the atmosphere, and then falls back to the ground in the form of precipitation. And once it's on the ground, it can soak into the soil, and over a period of 10 years, 100 years, or more, it works. Part of that is the cleansing process that cleans the water and makes it healthy for us to be able to drink again. process that takes it back down into the aquifer. On the surface, you have water that's traveling across the surface, plants on the surface slow it down so that it can perhaps soak back into the soil, or plants take it up and off moisture, and then that goes back into the cycle. And then we have this thing in the middle here. Very good. So most wells for our drinking water and for the water use that we have on our properties. And the way it and sucking up the water from there and bringing it up to the surface. So you can see that it has some kinds of effects on the aquifer, and it's, you know, pulling this water here from the aquifer that's quite old too, that's gone through this filtration process of, you know, many tens of years or more. So just for fun, we've got horses too, so that's just for fun. Yeah, raining. I knew. I didn't even think of that. Good one. Okay, so leading with that thought of the well and some of the that can come along with having a well and groundwater, getting your water from the groundwater or from a well, is potential contaminants can travel across the groundwater via the soil and soak into the soil and can contaminate our groundwater that way. Or contaminants can travel along the soil and travel down the casing and can cause a problem for our groundwater aquifers that way. Some of the things on horse properties that you might think of that could cause a problem water take much needed rain from one part of the country to other parts of the country. So maybe here our rain would go elsewhere. I mean, here we don't think it as much as, like, I live in Idaho now and we have seen where our rain is not there. Or other parts of the country, like most of the American West is experiencing some level of drought. And some parts are experiencing extreme, some of you folks know of if you have family there or friends. And at the same time, then the East Coast is getting more rain. So, you know, maybe the rain from those areas has shifted to other areas. So that's going to be affecting groundwater recharge. Pacific Northwest summers might experience a longer drought period, and this is a consideration for us. And conserve water, which we're going to talk about in a few minutes. And we should look at protecting wetlands and water bodies, as these are important recharge areas for aquifers. So the three sort of categories or main ideas for water-wise conservation on horse properties are to prevent runoff, so that you're not contaminating that surface water and then again your groundwater. Reduce chemical use as much as possible, so you're not risking contaminating your drinking water. And conserve on-farm water use. And all of this is to protect our groundwater and our aquifers. Okay, so let's look at some concepts. I'm not so much going to go into techniques as just kind of concepts and ideas. And I encourage you guys to, talk with any of the resource specialists and the farm planners that are here today, or later on when you go home, talk to your conservation districts and get help on any of these things, or get information if you're interested. So the most important thing for runoff, the first thing I'd say, is to think about just slowing the flow. And so many times, that's all you need to help solve a problem or make a situation better. Just slowing the flow of the water down many times is all that's needed to help that water soak back into the ground and into the natural hydrology of the situation. So here are some ideas, and I'll show you some pictures of some of these things. Some ideas for slowing the flow: footing and grass. I'll show you that. French drains, water diversion bars, grassy swales, native trees and shrubs, one of my favorite. Rain gardens, which are incorporating native trees and shrubs. Green roofs, which is one of Jay's favorites. And plants for biofiltration of dirty water. So let's look at some of those. So eliminating bare ground. I was really impressed with what Renee said there about the temperature of bare ground being 20 degrees hotter. These are just a few pictures at my place in southwestern Idaho. That's the Smile in Idaho, that people noticed where the temperature is a lot hotter. And a lot sunnier. And part of why I moved there was because I wanted to had been, the previous landowner had, in their attempt to get rid of weeds, had pretty much nuked everything else. There wasn't a blade of anything growing anywhere. And that's along a ditch bank or any place outside of the hayfield. So it was hot and it was dusty in the summers, and it's quite a bit of difference now because we have footing in any of the horse turnouts or paddocks, and that helps a lot with dust. And in any of the rest of the areas, even if they're not irrigated, we've planted grass, we've planted dryland grasses. So this helps with dust, it helps with heat, and then it also helps with runoff, because we do get rain in the desert, contrary to popular belief. And when it rains, it really rains, and you get a lot of runoff, and with that clay soil, you get a ton of erosion. So eliminating bare ground in high traffic areas, you guys if I didn't have to mic you guys all, I'd be asking you guys some of these questions, like I usually do. So here's an example of our places. This is now, and after we put in grass in certain areas. These areas did not have grass. The paddocks did not have footing. So that's just an example of the footing. So there's many different types of footing. Talk to your conservation districts or talk to other horse owners to see what's worked for them. But the point is that it helps slow the flow and helps water soak back in, prevents erosion, prevents dust. So planting plants in along buffers. So we have an irrigation ditch, and the previous owners had completely eliminated all vegetation along the ditch. So we've replanted the ditch with native plants, native grasses and flowers. We created a very useful here in the Pacific Northwest. The idea is that they capture runoff and divert it away. Again, they're slowing the flow. A French drain is basically a ditch in the ground filled with drain rock and has a pipe in it, and water flows to the path of least resistance. So it flows into that ditch and then is carried away. So you can slow the water down and put it someplace else on your property where it can go back into the footprint of your property. Water diversion bars, great idea. Very simple, just a way to slow the water down and redirect it to someplace where it's not going to cause erosion or get muddy. This is just on a driveway. It's not a horse thing, but there's ways that you can take these ideas and then run with them on your horse properties. So this is just a stall mat, about a foot thick, that Allan has put in his driveway because he has a steep driveway and it rains a lot in Muscatello, and that causes a lot of erosion and washes away his expensive driveway gravel. So he put in these water bars. They're basically like speed bumps for water, if that helps with the analogy. You could use anything that works for you. Think of the backcountry trail riding that you do, and you'll see water bars on trails, and that's the same idea. It's slowing the flow and helping to prevent erosion. Native trees and shrubs, put them to work on your property. They're going to be the best plants here for you in your area, wherever your area is, for the virtual audience as well. Those trees and shrubs are adapted to your climate, to the diseases in your area, to the animals in your area, so that they're going to be hardier, and you're going to have to use less water and no chemicals, basically. And Douglas fir trees, a mature one can use up to 250 gallons of water a day per tree in the summertime. And the good thing about evergreens is that they don't go dormant in the wintertime, and they're still using water in the wintertime. So they're helping again to put water back into your natural system and back into the hydrology of your property. And they're slowing the flow. This is just examples of native plants. how you can use them on your property. Plants for biofiltration, so you can take those same plants or other plants and use them to clean up dirty water and then help put that clean water back into the footprint of your property. These are some examples from non-horsey situations, but you can take these ideas and again incorporate them onto your property. This is a cool one that I saw in Virginia. It's a parking lot, and the runoff from the parking lot, instead of it just running into a ditch or a stream or something like that, where it could cause a problem, they took it and put it through a swale, which I hope you can see here, and it's just grass and plants. I don't know that it was native plants or anything in particularly, anything special, but it's this long swale here, and the soil, the healthy soil and the healthy plants will help break down oil or whatever might be running off that parking lot and act as a filtration system for that dirty water and clean it up. Same here, this is in Friday Harbor, so dirty water runs in here and hopefully clean or cleaner water runs out the other end. Wenatchee, Washington, and just in a parking lot there. When it rains, all the water runs into this vegetated area, and again, those plants and soil are going to help clean up that water. So here is a very smart horse owner who took these ideas himself. He never saw my classes. I mean, he's come to my classes, but he didn't see these ideas at my classes. He put them in place himself before I had even thought of it. And then I started putting it together after I learned from him. So he took the dirty water that was in his paddocks here. He put it in a culvert under his driveway. It comes out right here. And then he put it through basically a biofiltration system of plants. I mean, some of them were native, but a lot of them were like landscaping plants. And he made it a landscaping feature. And it cleans up the dirty water from his paddocks, and at the other end it runs into his pasture. So it's staying on the footprint of his property, he's cleaning it up. It's cool. Rain gardens, another great idea. So again, we can look at what's going on at public places, wherever we see rain gardens, and take those ideas and then look for ways that we can put those to work for us and help us at our horse properties. So rain gardens, their idea is to take clean rainwater and just hold it and slowly release it back into the environment, to the footprint of your property, using native plants. So here's on April's place on the San Juan Islands. And she takes the water, she channels it off of her driveway in different areas, and they've created a rain garden. That's the before, and this is the after. It'd be even prettier if all the deer didn't eat all of her lovely native plants that she planted there. This is what's left after the deer get done. Here's another example of a rain garden on a livestock property in Snohomish County. This is the rain garden. The gutters are directing water over here, and then that's what it looks like when it's full of water. So the idea is it's clean water and it slowly soaks back down into the ground. It shouldn't stay there longer than 24 hours on a rain garden, right, Brandy? About 24 hours or?
I'm not sure. Or less.
So it's not supposed to be a standing lake, in other words. Laura knows. Yeah, not supposed to be mosquito habitat. Okay, green roofs, another way to slow the flow and reduce runoff. So many good examples. People are starting to do it. Jay did it at his former place. So he'd be a great one to talk to afterwards if you're interested in a green roof. But many advantages to a green roof, and just one of them is that it's going to help slow the flow, help prevent as much stormwater runoff. Least toxic weed controls is the next thing I want to talk about, and these are just ideas to help you think about ways to reduce chemical use so that you're not putting chemicals into the environment as much, and you're not risking contaminating groundwater by doing so. So some of the good pasture management techniques that we've been talking about, those are key to weed control. The best way, the least toxic way to control weeds is to practice good pasture management. So that is establishing a sacrifice area, which is a confinement area. And as most of you guys probably know, this is the area that we recommend you keeping your horses or your livestock in the wintertime when your soils are saturated and your pasture plants are dormant, or maybe during a rain event at this time of the year when your soils get super saturated. Or it's where you put them in the summertime to keep your pastures from becoming grazed below that 3 inches that we were talking about in the pasture talk. Never graze below that magic 3 to 4 inches. That's what belongs to the plant, as Jay said. Rotational grazing, and keeping horses off of pasture in the wintertime. Those are your best chance at managing weeds. So when you do have weeds, you want to jump on it and do something to address them. So hand removing, if it's not too big of a problem, is the #1 least toxic way of controlling the weeds that are there. Weed burners are another good idea. Spot spraying with the appropriate herbicide at the recommended time of year, so you want to get advice from somebody who can help you with that as to what exactly your weed is and what exactly is the herbicide that you should be using to control it and when. And then integrated pest management, which is basically using beneficial insects, is another way to control different kinds of weeds, or at least help manage them. Okay, what's wrong with this picture? This is a friend of mine's place, and I mean, we're all friends, we're all in this together, and she just didn't realize what the problem might be here. She has a really nice place, and it was all very neat and organized, but this is her well house right here, and this is her well head. And this is gasoline cans. That most people just don't realize how easy it is to contaminate groundwater and how quickly this can happen and how serious it can be if your groundwater gets contaminated. And there's so many chemicals in this world, and there's so many that we don't know about or know how to get them out of the water once they get in the water, as evidenced by that spill in West Virginia, for one example. But so your wellhead, you want to maintain grass around it, and you don't want to store any chemicals. I think my friend April said that if you don't want to drink it, don't put it near your wellhead. That's just the easiest way to think about protecting your wellhead. More ideas for groundwater recharge and water conservation. Rain barrels right here. Again, this is my friend Allan from Snohomish Conservation District. Rain barrels are a great way to save water and to recycle a little bit. Cisterns, I'll show you some pictures of those. Pervious surfaces, outdoor wash racks, really a fun way. I'll show you pictures of that. Automatic waters and pasture irrigation. We'll talk a tad bit about that. Okay, these are cool cisterns, aren't they? This is at a place that we'll probably do a farm tour at in the next year or so. And it's in Auburn. It's like 1 acre, and they're trying to be sustainable on 1 acre, raising as much as possible their own food and harvesting rainwater off of these small roofs. And April also looked at this and said, only in Western Washington did you have cisterns that big and that small of a roof, right? So they're collecting the rainwater and then reusing it in their gardening and their animal care. Here's a homemade way, a simple, low-tech way of harvesting rainwater and reusing it. These basically are cisterns as well. They're just capturing the roof runoff They have a series of hoses, and then they use it for their horses. This place actually has city water available to them, but their horses wouldn't drink it. Interesting. Pervious surfaces, as much as possible, horses on something like this, but there may be parking areas and driveways or things around our homes that we can change from impervious surfaces to pervious. As much as possible, if you can think about that, that's going to, again, help with slowing the flow and recharging our groundwater, which is going to become so important as we go along.
Elaine?
Yeah.
If we install this as our driveway and our horses walk on it perfectly fine.
Oh, really? It's not slick?
No, it's not slick at all. Once barn, and once the turf got started perfectly fine, it drains beautifully. I certainly
There's more opportunity for the grass there to sequester carbon.
Yeah, that's true.
Maybe.
More sequestration possibilities than with this kind of situation. Again, this is pervious surface for parking areas. Outdoor wash racks, really cool ideas for reducing impervious surfaces. And then the grass around can help break down any soap, but my suggestion would be use biodegradable soap. So many different good ideas, and anytime you can avoid putting water into your sewer system, a public sewer system is a good thing. Here's another one. This is ours in Western Washington, or in southwestern Idaho, our outdoor wash rack. Because our wash rack in the barn does go into basically our septic system. So automatic waters will also help conserve water use because you don't have to dump a 50 or 100 gallon stock tank all the time. They're 5-gallon water pan. They're also going to have fresh water, so it's not going to be mosquito habitat. There's many different kinds, singles, doubles, many different brands. I highly recommend them. You can put heaters in them and they work great in the wintertime. You don't have to think about breaking ice. And irrigation, irrigate. How many of you guys do irrigate at least a little bit in the summer? Only a few, okay. So irrigation would be another way where we can think about conserving water use, particularly when it's our well water that we're using. Times of the day. To know when your soil needs to be irrigated, first of all, you want to keep your plants in that vegetated stage, so it is actually better if you do irrigate and they stay growing, rather than if they go dormant. It's better for the environment and better for aquifer recharge. The soil is going to be lighter in color when it's drier and darker when it still has moisture in it. And you can actually take a shovel out and dig down and look and see how far the roots go down and how the soil color changes. Another simple way to check for soil moisture is by taking like a 12-inch long screwdriver. And if you can push it into the ground really easily, your ground is probably pretty soft and probably still has a lot of moisture in it. But if you can't, that means it's probably pretty dried out. I mean, that's a primitive way to do it, but that's one way to do it. And it's a way to check it. So you don't need to water too frequently, but you do want to get all the way down through the roots, your plant's roots. So usually what's recommended is not more than once a week, and usually every 2 to 3 weeks is what the cycle is. little bit of a changing streams here and thinking about something different. Anybody know what this is? Sure. Yeah, it's Lake Mead. It's probably, there's not very much groundwater use that's going on in Las Vegas. A lot of us know that from personal experience that there's a lot of excesses in Vegas, although we're all attracted to it and we all enjoy it. You know, it's quite the playground for all of us. My friend Sherry and I have shown there. You drive up, we drive inside the building, we unload in the air-conditioned building, we unload our horses. They're in air-conditioned stalls, we show in air-conditioned arenas. You know how it is when you walk downtown in Vegas, there's the Bellagio and all that water and the shark tanks and the pirates. So why am I talking about Las Vegas, you think? Yeah, because Vegas is doing some very, very innovative and exciting things. And the reason why I bring it up is just to give you guys some ideas and some inspirations and some things to think about. Brandy and I read this cool book. Brandy told me about it, The Big Thirst, The Secret Life of Water. So many cool ideas and things to think about with water. Here are some of the things that Vegas is doing. Casinos and businesses are using treated, recycled water, either sewer water that they've treated and are reusing, or gray water that they're treated and reusing. Golf courses, and they have apparently like more golf courses than any city in the United States. And you know, golf courses use a ton of water with all that grass. So they're using gray water to water their golf courses. They are putting in xeric landscaping features, which is basically like desert landscaping. So they're pulling out the grass and putting in xeric landscaping. They're paying, the government, the city is paying landowners to take out grass. They call it cash for grass. They're implementing water-saving rules, like even the type of nozzle to use on hoses in the yard, and you know, not letting hoses just run to, and where to wash cars, and mandatory watering days. So the bottom line is Lake Mead, where they take water from, the city of Las Vegas was expected to run out of water, drinking water, by 1995. Now they are putting water back into Lake Mead. That's how well they're recycling and reusing, and that's the desert. So if Vegas can do it, we can do it in the Pacific Northwest, right? And every place else. Okay, so I hope you guys have, from this presentation today and from all these wonderful speakers who have traveled from faraway places, I hope you have gotten some ideas that will help you realize the big things that we do on our properties, as well as the little things, can make a huge difference. And these practices and the ways that we run our horse properties all add up, and they affect the water and the watersheds that we each live in. And the important thing to think about with that is that all of our watersheds are really all part of one big watershed that we call home. And it's a finite place, and we need to take care of the resources in order to keep it a wonderful finite place as well. And I wanted to quote and that was by one of my favorite explorers, Jacques Cousteau. And that's it. Can I inspiration. In 2012, I went to Australia and I came back with this great idea. But once I talked the King Conservation District into it, it's been their baby. And they have done an awesome job. So Brandy Reed and Nikki, they have just been unbelievable. They've made all of this happen, and you guys have made it happen, and the audience has made it happen. So and the speakers, so I'm really grateful to all of you guys to all put it together, and hope we can go forth and share these ideas and learn from this and learn more. Brandy, is there anything else you want to add? Or?
I'll just do follow-up logistics.
Okay, Brandy's going to do some follow-up logistics, so hang on. Thank you. Okay, that was great. I don't know about you guys, but I'm really pleased with how today turned out. This is new for us, this foray into conference territory, and also pushing our envelope a little bit in terms of taking on a topic which is not part of our traditional model at the Conservation District, which is climate change. And I'm looking forward to continuing exploring that. Our staff are, and I think that we have some really great stuff to work with here around being in was that, you know, that just in doing your pasture management, you're part of a group of people that are actively managing to improve the global system, which I think is the message that I hope we can all work on going. Part of this conference, but there's a couple of other things that are going to go on for the next hour, which you are invited to stay and participate in. So the first is that there's a tour of the facility here at Emerald Downs. So you are welcome to join in this tour that will go and look at the paddocks where the horses are and the veterinarian facility here at Emerald Downs. And what will happen is in 5 minutes, if you want to do that in 5 minutes, just head out this door here to the left and wait in that lobby, and there will be an Emerald Downs representative on this tour. For those of you who would rather hear another presentation on manure management and innovations in technology and systems around manure management, because as we remember from Gary's presentation, he was talking about waste management as being a pretty important piece of managing the health and well-being of your animals. And I know that you're all devotees of this sort of mud management, manure management, and pasture management system of practices that have been the cornerstone that have been preached by Elaine and by all the conservation districts in Western Washington and in Washington State in general. But we have a vendor here from Green Mountain Technologies who is going to stay in this room and talk about some of the innovations in manure management systems. So for those of you who would rather not go on the tour, we have that. And I just want to ask you all to help me. I don't know if all of our presenters are here. I know at least Gary's here, and I just ask you all to help me again. Thank all of our presenters for doing such a great job. Elaine and Gary and Chad and Nick and Sandra, our panelists, Jay and Aaron, and Jay and Renee. But you can go.
the newer market.
Just so that people can have something to look at.
management. It was covered in the water quality presentation quite well, the runoff of the nutrients that are in the manure or left out on the fields, whether you're cleaning the stalls and putting in a pile or fields. And, you know, are they good or bad? Well, of course, they're necessary for growing, and yet if you oversaturate, then we're in trouble with that. How this, you know, the two big bad boys are the nitrogen and the phosphorus, and they end up, the nitrogen goes both atmospherically and into the water, and the phosphorus is in the water. And this is what happens, is the algae blooms. And so a lot of the study that has been done recently is in the state of Maryland, because the Chesapeake Bay is in, you know, dire trouble. And it's through the eutrophication, you know, this excess of algae growth. So anyway, I'm trying to get to the point of the matter here. And, you know, everywhere you go, whenever I travel around the country, the first thing I do actually is check in with the local conservation districts, because they really are up on what's happening, what the farms are using, what trouble they're having. And they've all got their regulations, which can be you can find them readily online. They offer best management practices, which really amount to much of what was gone over today. And really your options come down to hauling off site or treating on site. And hauling off is what is killing a lot of people. My focus really has been more on the business side of things and the larger horse centers. But I certainly talk to many people that have 1, 2, 3, 4 horses. And interestingly enough, it all comes down to the same problem, which I'll identify in just a minute. So the parameters that have to be considered, obviously the cost of the systems. If you're in an area where you have to have very strict odor control, vector control. For some of you, I didn't know when I first started this what vectors were, you know, vermin and vectors. So anyway, it's, you know, the rats. Martha's Vineyard, we do a lot of work. They don't have rats, but they have skunks, population of skunks. Anyway. Has been documented really to be poor management practices of not cleaning enough. So that again goes back to the answer that we got today about really what you put this compost on is more what's going to create the problem. If you have the ability to use it as a soil amendment on site, whether it's for landscaping or to help your fields, and you're paying for that, then you can account for the saving in that cost. Also creating a saleable product. So the options really for doing that are in-vessel composting or site-built composting. Now this is a pretty fancy one that actually has attributes of the in-vessel composting. Health, and that's again goes back to one of the questions I asked today. There has been a local study done on the health benefits of bedding reuse, and they did find a decrease in skin and hoof issues, also respiratory issues. And I have further information I'd be happy to share with everybody on that. I can send you to the link actually on that study.
Is that for
horses or dairy cows?
It was for horses, I'm sorry. Yeah, this was for horses. How we do that is really controlling the temperature, the moisture, the mixing, and the aeration is how we, in part, control the temperature and the moisture. So, as I went through this whole, adventure of moving from a horse person who had a stable of about 45 or 50 horses, I actually didn't count in the end because I didn't want to know. But anyway, I did that for 30 years and ran into So we have treated our material, now what are we going to do with it? And this is, people have come up to me today who might have 2 horses and say, okay, this is great, but what am I going to do with the material? And it is an enormous problem when you start thinking of a place like this racetrack. When you go back east, there's much stricter regulations. So there are racetracks that have been closed down on the East Coast because of waste management issues. So my job became really finding the answer to that. And I have spent incredible amounts of time working with researchers, working with government officials, trying to figure out the answer of helping the private sector create the infrastructure that can deal with what the government is asking them to do, which is to take care of that waste. And it's been a very interesting and challenging thing to do. So on-site use, bedding reuse, more research is being done on that. Field enhancement certainly is obvious if you've got the space to do that. Land reclamation, and to give you an example of that, we have barns back east that are taking over covered landfills and reclaiming that as pasture land. A lot of that reclamation was done with stable waste, composted stable waste. We have a barn that has done the same thing when they took over an old gravel pit site. So off-site use, sale of soil amendment, an amazing find was to learn that stable waste is one of the best bulking agents for food waste composting. And with the rise in food waste composting and the cost for them of finding a bulking agent, this could be a very good link. Land reclamation, a lot of compost sites are working directly with the Department of Transportation in various states to supply them with the material that they need for whenever they dig up new areas for highways, a quick way to get vegetation growing without having to do that spray stuff. And again, landfills, covering of landfills and gravel pits.
What's a bulking agent?
A bulking agent is what you add to any composting material that needs increased porosity. So you're creating airspace. So it has a, it's usually more fibrous. So instead of, if you think of really soggy food waste and you're putting in wood chips, so the market development, probably what many places are waiting to see is that we have partnered with Maryland Department of Agriculture on a couple of projects, and the most, I think, promising one is sourcing of food. House growers everywhere are, the industry itself is growing rapidly. So in the Maryland area, they are really trying to create the food for Washington, D.C., Baltimore, and Philadelphia. And the greenhouse growers could literally absorb the compost that is made in that highly dense area, very high horse concentration, enormous poultry concentration. And we're trying to prove the validity of that with this study we're doing with Department of Ag. And what's interesting too is one other step in Maryland is the Maryland Environmental Services has put together their own composting project with leaf compost, which is really the easiest thing to do. And they are now looking, that has been so successful that they are now looking at us doing a pilot project with them to break down and compost the poultry litter, which has all kinds of problems in itself, to mix in with their leaf waste to start creating a new product. So we have found that this partnership can be nurtured between the government and the private sector in trying to solve these problems. And I think that for the small horse owners, where the really could be value to your waste instead of just money going out of your pocket. This is just an example of the Massachusetts mass balance sheet that they look at, and they study this. It's just fascinating how in-depth it is. I'm not a scientist, so I find, you know, I'd be happy to share any more of this information with anybody who's interested, but I was trying to be quick to show you what is coming in the future and the fact that there's hope for making it financially viable for you and even the larger barns such as Emerald Downs. Thank you. Any questions?
This is separate. I'm familiar with the company in Whatcom County, Dairy Tech, that has built the.
Oh, yeah.
They called it the Betting Master, and we've got some dairies through the museum. This is a separate venture with you kind of creating your own technology. Is that correct?
Yes, that is correct. And Dairy Tech runs a drum system, and the difference, very basic and simple way to explain it, is that the product that comes out of their drum needs curing time. And the product that can come out of one of these earth flows is a stable product. In a Solvita test, it's a 7 or an 8, which is the highest score you can get.
Do you have some more information on that system?
Yes, I do. Right in the back. Happy to hand it to you.
Do you have any slides that you can show us?
You know, I do. More than so. Anyway, but I have it back there. I'm happy to show you.
So in some respects, this would be a little bit similar to some of the plug flow anaerobic digesters. I mean, it's not using the same process, but it's a similar technology in that you put material in it, it kind of moves in a plug, and then comes out at the end and it's in for a certain retention time.
Exactly. This system right here is used on at a facility that has 15 to 20 horses. And so every day they're able to load it on one end, and either every day or every other day they run the discharge cycle and get some out the back. Believe it or not, this runs through this system in 10 to 14 days. Yeah, and this gentleman, what's really fun, it's one of the case studies that it's in the back, and this gentleman decided not to do bedding reuse because he sells it to the local landscapers, $20 a yard wholesale and $30 a yard retail. So he's like, well, that's a lot more than I get for replacing my sheepings.
How long has he been doing that, selling it?
For about 2 years.
So he's getting some repeat customers.
Oh, absolutely. Everybody loves it. Actually, this is on Bainbridge Island, and if you know Bainbridge Island at all, they're very picky, gardeners and people who hire landscapers that want perfect, pristine Gardens, and the weeds, the thing that they love about it the most are the weed seed kill in it. You just do not get weeds, which of course is completely opposite of what most people think of picking up horse manure compost.
So this is a system that you sell, is that
Yes.
correct? Is that the only system that you sell?
No, we do, when I showed you the site-built system, we did, this is, you know, a pretty high-tech, expensive machine, and we wanted to come up with a less expensive alternative, and so we went to what we call a site-built system. And it contains the automated internal auger system and all the controls, but it's done on a concrete pad with concrete walls and just a hoop house over it. And it's very easy with the site-built to make it 10 feet long or 90 feet long.
So for a system that is for a stable with 10 horses, what would it cost?
I would do a site-built probably.
Could you repeat the question?
Yes. She asked what would be the size of a system or the price of a system for 10 horses. And you are right on the cusp of affordability because you're looking at a site-built system that's still going to cost you probably $35,000.
Oh, yeah.
Yeah. Well, that's the, you know, that's the concrete and everything. Now, if you're really lucky and you're at a farm that you have concrete bunkers, then the system can be built into that already. So a lot of that cost is the infrastructure cost before you even get to the technology.
So, did I get this right? For 10 horses, $35,000. And what's the cost of that beautiful system right there?
The smallest one of these systems will range anywhere from $39,000 to, you know, $140,000. And where it really pencils out, or you know, when people are under scrutiny of regulation, right? The enforcement is there, and they are paying. I have barns that are paying $2,500 a month for haul-off fees.
How much?
$2,500 a month.
How big a barn?
That's with about 25. And that barn's in Kirkland.
Say that again, please. And
Produce with that many horses, if they can find a contract buyer who will come in and that money goes in their pocket, and their ROI, their return on investment, starts looking pretty darn good.
so what's a typical sales price for a yard of the material like this?
Like I said, we have found it to be pretty true across the country, some variation obviously, but $20 wholesale and $30 retail is on, I would say, on the low side. He has no problem getting rid of it for that price. He could probably charge more. You have to remember that if you go and buy it, if you order it from a lot of landscapers, they charge up to $60. County Conservation District, but I was told that he was being given funded $1,000 per horse to go towards if he indeed bought a system like this to control the you know, the waste management.
I think that what you're referring to is the Keene Conservation District cost share program, or possibly.
Yes, exactly.
Are you contracting with anybody on a system like this?
Not for
Through
anything
Keene
like
Con-
this, not
Yeah,
yet.
so it's the KCD cost share program, and the cost share program is set up to enter into a practice implementation relationship with the landowner, and this one would be around manure management. And it is a pilot for us to get into this territory and figure out whether or not this is a viable structure approach to manure management and composting on a facility where it might not make sense to put in our standard bin design and remember where exactly to try this. And we will be looking for some, some feedback, and some data to help us understand whether or not this is an investment that we want to start using. Whether or not this is an investment we want to make in this type of a technology in situations where it seems like the other sorts of technologies that we're investing in for composting systems aren't going to work. They're not viable.
Randy, is there a cap on that cost sharing?
So for manure management at the King Conservation District, the practice is capped. We fund that practice on an animal unit basis, so it's $1,000 an animal unit. So average horse, 1 animal unit. If you have 10 horses, you'd be eligible for reimbursement up to 10 animal units, $10,000. So, and it's a manure management practice. I believe we have a cost share ratio of 75%, 25%, meaning that we'll pay for 75% of the total cost, and 25% of the cost is paid for by the landowner. So it's up to $10,000 with 75% of that from the KCD and 25% with the landowners.
And 10,000 is the maximum?
In that situation, it is because it's based on the animal units, the number of animal units. So if they had 5 horses, it'd be 5 animal units. If they have 20 horses, it'd be 20 animal units. You can see that we were not really set up. We didn't set up our cost share program to do this kind of work. This is new territory for us. We're exploring it because we think that it may have application in certain situations. We aren't going to do this for every landowner because a lot of landowners can get by with a different type of a composting system. But so we may very well have to get into a situation where we have to put caps in place, like a maximum amount, not just an animal unit per animal unit reimbursement rate, but a maximum project cost also.
So I had a comment and a question. So at King County, we actually did, our wastewater treatment division did a pilot project with the dairy law. And as many solids, and then what they can do is they can put the solids into their bedding master. So we're helping with a pilot project there to see if that might be replicable with other dairies. Wouldn't do anything for horse owners. But I did have a question. You had referenced sort of some dollar amounts for cubic yards of material, and I want to be careful not to sort of pit companies against each other, but there's a large local composter that's indicated that they really struggle to sell compost, because of the volumes, and that the dollar amounts are quite a bit lower than what you referenced. And I'm just wondering if you could sort of talk about maybe the nutrient the nutrient components, or maybe the differences in the products, without trying to step on toes, but just learn a little bit more about it.
Right, and especially out of equine waste, you're really talking about a mulch. You're really talking about a mulch, not a fertilizer, or you even have to be careful with the soil enhancement because it depends on what you're trying to do with it. And remind me if I get off track here on what your question was, but prices and markets for the product, are going to vary tremendously. And I will tell you that the interesting thing, which in some ways helps fit together really some of the places that are struggling the most with their waste management, are in urban locations. They are within housing developments that are next door, or you think of this one barn in Kirkland. It's on I don't even know if they have 2 acres. I bet it's an acre. I don't even know if it's an acre. It's the smallest thing I've ever seen, and yet they have 45 horses. But anyway, but the market in that area is really strong for a mulch material because of the landscaping that's done. So I don't know if I'm answering your question.
You are. Actually, the one thing that I'm realizing is that this is definitely source controlled. it's the stall waste, you know exactly what's going into it. It's,
Right.
it's the manure and bedding and, wood product or whatever from on site. The larger composters are trying to deal with these plastic issues that are coming from the post-consumer food waste and stuff, and they're having huge issues with that. So that would also play into that material could not go onto the landscape and please the Bainbridge customers, because visually they don't want to see shards of plastic. And the material with this is going to look black or sort of dark brown and uniform. So that explains some of it.
Absolutely, and I think just to take what you're talking about a step further, and what is exciting, you get these collective sites. And you're looking at the product. We have a dairy we're working with in Minnesota, and they do screw press, separation, and yet they also add the scrapings out of their stalls. So they have, there's a couple different mixtures that go into what they want to compost, but specifically they have a market to sell it, and they want to sell it to other farms in the area. And one of the things I learned back in Maryland, is a very archaic system, but their Department of Ag offers a service where farmers can literally post, I'm short this much nitrogen, or I need this much phosphorus, or whatever, and they're trying to pair who has what can go where. Somebody's waste is worth something to somebody else. So, yeah.
So, the people that are selling this for $20 a yard or $30, what are they selling it as?
As mulch.
Strictly as mulch?
It's top dressing, and what anybody who's used it that I have spoken to has found. I mean, it's great. Plants grow wonderfully. There's no weed seed. There's, what the real nutritional value is. I'm sure someone who produced fertilizer would stand here and, tell me that if there was a barrel of summer flowers, they're going to be a foot taller with their fertilizer than they are with this material. But it has been a resounding success for the clients that we have had, which are numerous now that are out there selling it, and the people that are using it.
So, Rick, the people that you said were having trouble selling it, what are they selling it as? Mulch or something else?
I think the majority of that is sold as a soil amendment that would be tilled in, but there are a lot of questions related to it. I mean, anytime that even when you're taking a large scale and you're heavily monitoring it and testing it, it varies a lot by season depending on how much is coming in as, say, sort of fall wood waste without green in it, and they're trying to mix it. So I think typically they're selling most of it as a soil amendment that you would till in, but if you're looking at it from a nutrient standpoint, nutrition, or
anyone to do, because it was United States Army. So the caisson horses, the one that are the ceremonial horses, they draw the caskets through the military. They're all housed places. They chose Meyer Henderson to do the study at, because they were then going to segue off into the stable waste composting. So the good news about working with the Army was that every known test, possible, and I really think they made some up as well, had to be done, because this product was going to be put on Arlington National Cemetery, federal public land, and they wanted to know inside and out what was in that material.
What were they going to do with it at the cemetery?
Help with the landscaping with the grass, and mulching the graves.
May I ask her?
Yes.
So this would be probably used in place, like when you're putting in a rain garden and they're talking about how you want that top layer, and usually we encourage people to use wood chips as opposed to beauty bark, would this be kind of in that same zone, that kind of top layer of stuff? So you've got your French drain and your water-loving plants, and then you put this wood chippy kind of mulchy stuff on top to help soak up, and because the wood chips actually they puff up with water and they soak up the water and hold it really well. So is that kind of the
Yeah, and I mean, there's
position
enough
of-
nutrients in there that the grass will grow. When I've looked at, I have pictures taken of, especially this gravel pit reclamation it was literally, the stable waste out of that unit was put on it, and it's remarkable, the grass that grew out of that, and there was no additional fertilizer used, so.
Now, that system right there, they
Yes.
use, what do they use for bedding in that
Shavings.
farm? So it's wood shavings. Okay. So do you have any experience with systems where they're using the composted material as bedding and then composting it again?
Yes, we used this in the trial that was run by a PhD candidate at Washington State University last summer. She would actually come down and pick up this material, take it to a barn and use it there and bring it back to us and run it through again. And we found that, it certainly after 3 or 4 times through the system, we were getting finer and finer material. And that's why for bedding reuse, we always recommend that it's about a 40-60 mix. So it's 40% reused bedding or compost and 60% new material.
And tell me why again? Why
To continue to introduce the integrity of the shavings.
And how do the shavings improve things?
Well, because otherwise you're going to end up eventually with dust, right? I mean, if you just kept reusing the same material, it's going to degrade every time it goes through the system.
Okay.
So just to keep the system alive and going, you've got to feed it with new stuff. So one place that has it actually decided to screen, and what the product was that they sold were the screened fines. So they would use literally what looked like wood chips still as the bedding, and then sold the fines as the soil amendment.
So they kind of winnow it out. And
And that's, obviously removing more of the nutrients to go to the soil
it
and
seems
the
like there's
bedding.
a lot of synergy with the rain garden stuff and the splash boxes and things that King County is really looking at heavily. I do rain garden or stormwater stuff, so I'm intrigued.
Mm-hmm.